The universe may not be expanding. It may be inhaling right now, not metaphorically, not poetically, but physically, through time itself. For nearly a century, we have told the same story with growing confidence. Galaxies are moving away. Space is stretching. The universe began with a violent expansion, and it has never stopped. Every telescope, every redshift measurement, every equation seems to repeat the same quiet sentence: everything is flying apart. But what if that sentence is incomplete? What if what we are witnessing is not expansion but a phase? A single moment inside a cycle so vast that it tricks the human mind into believing it is permanent. Imagine watching a chest rise, but never long enough to see it fall. From your perspective, breathing would look like endless growth. Not because it is, but because you arrived in the middle of an inhale. This is the question we begin with tonight. What if the universe isn't expanding but breathing? If you're listening to Whispers of the Universe, and this quiet place feels meaningful to you, take a moment now to support it. Please like this video, share it with someone who drifts through questions like these, and subscribe to keep this space alive. Your small gesture helps this universe continue to breathe. We are taught that redshift means distance. Light stretches because space stretches. The farther a galaxy is, the faster it appears to move away from us. This relationship is elegant, measurable, repeatable. It is the backbone of modern cosmology. And yet, hidden inside that explanation is an assumption so familiar that we rarely notice it anymore. Time is steady. Time flows evenly. Time does not change. But what if time is not the silent backdrop we think it is? What if time itself stretches and contracts not rapidly, not violently, but so slowly that entire civilizations rise and fall before it completes even a fraction of a cycle? In such a universe, light would still redshift. Galaxies would still appear to separate. Distances would still grow on paper. But the cause would not be space alone. It would be delay, aging, a subtle lengthening of the intervals between moments. Photons would not just travel through space, they would travel through time that is slowly loosening its grip. To a creature that lives for less than a century, this would be indistinguishable from expansion. We would build equations around it. We would name it. We would stop questioning it. And that is exactly what makes this possibility dangerous and fascinating. Because the Big Bang, as powerful as it is, depends on time behaving itself. It requires a clean beginning, a sharp arrow, a universe that starts fast and never looks back. But a breathing cosmos does not need a beginning in the same way. It only needs a rhythm. Inhale, pause, exhale, pause. Each phase lasting billions of years. Each transition too slow to feel, too vast to witness from the inside. We might be living inside the gentlest slope of an inhale, where everything appears to accelerate outward, not because the universe is fleeing, but because the tempo of time itself is changing. This would mean that our most trusted observations are not wrong, only incomplete. The cosmic microwave background would still exist. But instead of being the afterglow of a single explosive birth, it could be the thermal memory of a previous breath. A faint warmth left behind when the universe last exhaled deeply, before settling into silence and turning around once more. Dark energy would still dominate the equations, but instead of being a mysterious force pushing space apart, it might be a placeholder, a name we give to the effects of a deeper oscillation we have not yet learned how to measure. Even acceleration would make sense. Breathing does not happen at a constant rate. Inhales speed up before they end. They always do. The unsettling part is not that this idea challenges the Big Bang. Science is built to survive challenges. The unsettling part is that this idea challenges our sense of permanence. If the universe breathes, then expansion is temporary. If expansion is temporary, then contraction is inevitable. And if contraction is inevitable, then beginnings and endings lose their meaning. What we call now becomes just a narrow window between two incomprehensible motions. You and I would not be living at the dawn of everything, nor near the end of anything. We would be living inside a transition so slow that it feels like stillness. There is a quiet humility in that thought. Entire histories, stars, galaxies, life itself unfolding inside a single breath of something far larger than all of them combined. And here is where the question turns inward. If the universe breathes on timescales that dwarf comprehension, what does that say about the way we interpret motion, progress, and change? We often assume that direction implies destiny, that movement outward means growth, that acceleration means purpose. But breathing has no destination. It only has balance. Perhaps the universe is not trying to become something else. Perhaps it is simply maintaining itself through rhythm rather than expansion. This would explain something we rarely talk about: why the universe looks almost the same in every direction, why its laws seem finely balanced, why chaos never quite wins. A breathing system resists extremes. It does not explode forever. It does not collapse forever. It oscillates, and oscillations leave signatures that look deceptively simple when viewed from too close. From inside a single breath, everything looks like a straight line, but lines only exist when curves are too large to see. Tonight, we are not trying to overthrow cosmology. We are doing something quieter than that. We are loosening one assumption, the one so familiar it becomes invisible, and we are watching what happens when it is finally allowed to move. The assumption that time is steady. The assumption that time is only a ruler. The assumption that time cannot swell, cannot soften, cannot tighten its grip. Because once you allow time itself to change, the universe stops looking like a simple headline, expanding, accelerating, escaping, and starts behaving like something with rhythm. Not a rhythm you can hear, not a rhythm you can feel. A rhythm so slow that even the oldest stars are born and die without ever realizing they are inside it. And if that rhythm is real, then our most trusted evidence does not vanish. It remains exactly where it is: the redshift, the faint microwave glow, the pattern of galaxies across the dark. But the meaning of that evidence shifts, almost imperceptibly, like a shadow moving when you thought the room was still. In a breathing cosmos, distance is not the only way to create a redshift. Age becomes another way. Delay becomes another way. Because light is not just something that travels through space. It is something that endures time. It survives every interval it must cross. It carries the cost of each moment it has to wait through. So if time stretches even slightly, a photon does not simply arrive redder because space is wider. It arrives redder because the journey contained more time than we thought. Not more miles, more moments. And that is where the thought becomes quietly unsettling, because it implies something we almost never say out loud. When we look out at distant galaxies, we are not only looking back in time, we are looking into a time that may not match our own. A foreign tempo, a different tension in the fabric of now. A place where the intervals between moments might be longer or shorter than the ones ticking inside your chest tonight. If that is even remotely possible, then one question rises above all the others, and it does not let go. When we say a galaxy is moving away, are we measuring motion, or are we measuring the way time dilates across the universe? Because the redshift, in that case, is no longer just a ruler for distance. It becomes a symptom, a fingerprint of a deeper oscillation, a slow inhale that makes every faraway signal arrive a little older than it should. And if redshift can be read as delay, then the universe has been whispering something at us this entire time, not through explosions, not through violence, but through the most patient language it has: light. Which means the next step is not to argue about whether expansion is real. The next step is colder, more precise, and far more dangerous to our certainty. We have to ask what redshift truly measures when time itself is allowed to breathe. And to do that, we have to follow one photon, not across space first, but across the changing thickness of time. Because somewhere inside that stretched out journey, the universe may have been revealing its rhythm all along, and we simply mistook it for distance. Because once you decide to follow a single photon through time, space quietly steps aside, not disappears, just stops being the only thing that matters. A photon is born without mass, without memory, without choice. It does not age the way we do. It does not feel the passage of moments. And yet, It cannot escape time. Every interval it crosses leaves an imprint, whether the photon is aware of it or not. We usually imagine that imprint as distance. Light leaves a distant galaxy. Space stretches while it travels. By the time it reaches us, its wavelength is longer, its energy lower, its color shifted toward red. The story feels complete, clean, satisfying. But there is another way to tell the same story, one that begins not with space, but with delay. Imagine that the photon leaves its source at a moment when time itself is slightly tighter than it is here. Not dramatically, not enough to shatter physics, just enough that each tick along its journey lasts a little longer than the ticks that measure your present. From the photon's perspective, nothing unusual happens. It moves at the same fundamental speed. It obeys the same rules. But the medium it travels through is subtly changing, not stretching outward, loosening. As it moves, the intervals between events expand, the gaps between moments widen. The photon arrives not having crossed more space, but having endured more time than expected. To us, the effect is identical. Its wavelength is longer, its energy is lower, its signal is redshifted. And this is where the danger lies, because our instruments cannot tell the difference. A spectrograph does not know whether a photon was stretched by space or delayed by time. It only knows that the wavelength has changed. We interpret the cause because we assume the backdrop is fixed, but assumptions are invisible until they fail. If time is elastic, even slightly, then redshift stops being a ruler and becomes a symptom. A sign that the tempo of the universe is not uniform everywhere. Distance still matters. Motion still exists. But they no longer carry the entire explanation alone. This idea feels unsettling because it reframes something we rely on deeply, the belief that now means the same thing everywhere. We talk about the age of the universe as if it is a single number, 13.8 billion years, spoken confidently, written into textbooks, but that number already hides a quiet truth. It is an average, an inference, a reconstruction based on signals that have traveled through regions we will never touch. If time breathes, if it oscillates, thickens, thins, then age itself becomes local. Not in the relativistic sense we already know, but in a slower, deeper way. A way that unfolds over cosmic cycles rather than velocities. Some regions would age faster, some slower, and light, passing through them all, would carry that unevenness forward. We might already be seeing it. The slight anomalies in redshift data, the tensions in cosmological measurements, the disagreements between methods that should, in theory, agree perfectly. We call these problems. But problems are often fingerprints, and fingerprints imply presence. This is where the thought sharpens. If redshift measures delay as much as distance, then the further we look, the more alien time becomes. Not because physics breaks, but because the rhythm changes. Distant galaxies are not just far away, they are embedded in a different tempo. Their seconds are not our seconds. Their nows are not synchronized with ours. And the deeper we look, the more pronounced that mismatch becomes, not abruptly, but cumulatively. Billions of years of gentle divergence. This would mean that the universe is not unfolding on a single clock. It is breathing on many, all loosely coupled to one another, rising and falling together over spans so long that coordination appears eternal. And here, something subtle but profound emerges. If time itself participates in motion, then expansion is no longer a direction. It is a phase, one half of a cycle whose other half we have not yet learned how to read. Which brings us to the story we tell about beginnings. The Big Bang is often described as a moment when everything started: space, time, matter, energy. But in a breathing universe, such a moment becomes ambiguous. It may not be a start at all. It may be a transition, a turning point between contraction and expansion, an exhale becoming an inhale, a release followed by recovery. The universe would not need to explode into existence. It would only need to change direction. And the evidence we use to anchor the Big Bang, the redshift, the background radiation, the large-scale structure would still be valid, but their meaning would shift from origin to phase. This is not a denial of observation. It is a reinterpretation of rhythm. And reinterpretations are uncomfortable because they do not destroy what we know, they rearrange it. They force us to ask whether we have mistaken the middle of a process for its beginning. Because if the universe breathes, then there have been inhales before, and before those, exhales, and before those, stillness. Not emptiness, not nothing, just a pause between motions. A pause so long that even galaxies forget how they arrived there. And if that is true, then the cosmic microwave background stops being an afterglow of creation and starts looking like something else entirely. A residue, a warmth left behind by a previous state of the universe, not born in violence, but released during transition. But that thought leads somewhere dangerous because it suggests that the universe remembers its past in ways we do not yet know how to read. Which means the next question is unavoidable. If time can stretch enough to redden light, can it also stretch enough to carry memory? Because if it can, then the universe may not just be breathing, it may be remembering, and that possibility waits quietly ahead, folded into the faintest glow of the sky. At first, redshift feels simple. Light stretches, wavelengths grow longer, colors slide gently toward red as distance increases. It is one of the first cosmic relationships we learn, comforting in its clarity, elegant in its symmetry. The farther something is, the more its light appears shifted. Distance becomes readable. The universe becomes measurable. But simplicity can be deceptive when it rests on a silent agreement, because redshift does not say why light stretches. It only tells us that it has. We fill in the reason afterward. We say space is expanding. We say galaxies are fleeing from one another. We say the fabric between them is being pulled wider and wider. And all of that works as long as time remains untouched. But what if redshift is not a measure of distance alone? What if it is a measure of delay? Every photon we observe began its journey somewhere else, someone else. It crossed billions of light years, yes, but it also crossed billions of moments. And those moments are assumed to be identical to ours. That assumption is rarely spoken, but it is everywhere. 1 second here is 1 second there. One interval now is one interval then. Time is the same medium everywhere it flows. But physics already whispers that this is not strictly true. We know that time slows near massive objects. We know it dilates with speed. We know clocks disagree depending on where and how they move. Yet we quietly assume that, on cosmic scales, time behaves politely, smoothly, uniformly. As if the universe agreed on a shared tempo before it began. A breathing universe would not make such an agreement. In a breathing universe, time would not be a background, it would be a participant, stretching slightly during certain phases, tightening during others, doing so slowly enough that no single observer could notice the change directly. But light would notice, not consciously, not immediately, only cumulatively, because light does not skip moments, it endures them. If the intervals between moments gradually lengthen along a photon's path, then by the time it arrives, it will appear older than it should. Not because it traveled farther, but because the journey contained more time than expected. Redshift, in that case, becomes a clock error, a mismatch between the tempo at emission and the tempo at observation. And this reframes something quietly profound. When we say a galaxy is moving away, what we really mean is that its light arrives stretched. We infer motion because motion is the cleanest explanation available, but not the only one. Delay can mimic distance. Aging can mimic motion. Time dilation can masquerade as expansion. Our instruments cannot tell these stories apart. They only report the outcome. A longer wavelength, a lower frequency, a photon that arrives tired. So we build a universe where everything is running away, because that universe fits the data, and because it fits our intuition about beginnings and endings. But intuition is shaped by scale. We live in a world where changes are fast compared to lifetimes, where causes and effects feel tightly linked, where motion implies intention. On cosmic scales, none of that holds. A breathing universe would change so slowly that even the longest human history would register as stillness. No expansion felt, no contraction sensed, only a quiet drift that looks linear because the curve is too wide to see. This is why redshift is so dangerous to overinterpret. It is a single symptom trying to describe a system with more degrees of freedom than we allow. Distance explains it neatly, but time could explain it deeply. And depth often looks like unnecessary complication until it suddenly becomes unavoidable. Because once you allow redshift to mean delay, a cascade of questions follows immediately. Why does redshift increase so smoothly with distance? Why does it appear isotropic, nearly the same in every direction? Why does acceleration appear at all? In an expanding universe, these are features. In a breathing universe, they are necessities. An inhale does not happen unevenly. It does not favor one direction. It accelerates toward its turning point. If time is stretching globally during an inhale phase, then the farther a photon travels, the more stretched time it must endure. The relationship would look linear at first, then increasingly steep, exactly as we observe. Which raises an uncomfortable thought. What if dark energy is not a force pushing space apart, but a name we give to the late-stage acceleration of a temporal inhale, a placeholder for a rhythm we do not yet know how to describe mathematically? This would mean that our cosmological models are not wrong, they are incomplete slices through a process that has more phases than we allow. We have built equations for the inhale, without knowing it was an inhale. And we have not yet learned how to listen for the exhale. The universe, in this view, is not telling us it is escaping from itself. It is telling us it is midway through something. And the deeper we look, the more we are forced to confront a quiet limitation. All our measurements are made from inside the same phase. We have no data from the turnaround, no records from the deepest contraction, no witnesses to the pause between breaths, only light stretched, delayed, slightly off from expectation, carrying hints that something about time is not uniform across the journey. If redshift is delay, then the universe is not just larger than we think. It is temporally uneven, and that unevenness would have consequences far beyond cosmology. Because if time breathes on cosmic scales, then the laws built on time, causality, entropy, even stability, may also breathe with it. Which means before we ask what the universe is doing, we may need to ask what time itself is allowed to do when it is no longer assumed to be constant. And that question does not stay confined to light for long. Time is usually treated as the one thing that does not participate. Space bends, matter clumps, energy transforms. But time, we are told, simply flows, quietly, uniformly, indifferently. This belief is so deeply embedded that most cosmological models never question it. Time is the axis along which everything else evolves, not a substance that evolves itself. It is the ruler, not the material being measured. And yet, this is precisely where the breathing hypothesis begins to press. Because if time is elastic even slightly, then treating it as a fixed backdrop becomes the largest assumption in modern cosmology. The Big Bang, in particular, depends on this assumption more than anything else. It requires a moment where everything begins, a moment where time is already there, ready to start counting, a moment where the clock exists before the universe does. We rarely pause to notice how strange that is. The Big Bang is not just a story about space and matter. It is a story about time behaving perfectly from the very first instant. No hesitation, no fluctuation, no rhythm, just a clean, monotonic arrow pointing forward. But arrows are abstractions, and time, if it breathes, would not draw straight lines. It would oscillate, not back and forth in a way that breaks causality, but in a way that changes the density of moments. Periods where intervals stretch, periods where they compress, all without reversing direction. An inhale does not move backward. An exhale does not undo what came before. They change pace. If this is allowed, then the Big Bang begins to look less like a birth and more like a transition. Not the creation of time, but a turning point within it. This idea is unsettling because it dissolves the comfort of a clean origin. We prefer beginnings because they give us narrative control. They tell us where the story starts. They imply intention. But a breathing universe does not start. It cycles. And cycles do not offer a privileged moment to point at and declare, "This is where everything came from." Instead, they offer phases. Expansion becomes one phase. Contraction becomes another. Stillness or near stillness becomes the hinge between them. The Big Bang, then, may not be a singular event but the most recent hinge we can infer from inside the inhale. This would explain something that has always been quietly awkward. Why the initial conditions of the universe appear so finely tuned. Why densities, temperatures, and fluctuations align with astonishing precision. We usually explain this by invoking inflation, a brief, violent expansion that smooths everything out. It works mathematically, but conceptually, it introduces yet another assumption, that the universe needed an extra mechanism to correct itself immediately after being born. A breathing universe would not need correction. Oscillatory systems naturally seek balance. They overshoot, then return. They smooth themselves over time. They erase extreme irregularities simply by continuing to cycle. Fine-tuning would not be miraculous. It would be inherited. The universe would not be starting fresh, it would be continuing. This reframes the cosmic microwave background in a subtle way. Instead of being the afterglow of a singular creation, it could be the thermal echo of a previous state. Not a birthmark, but a memory imprint. A residual warmth left behind when the universe passed through a denser, tighter phase before relaxing again. Not an explosion, a release. And if that warmth is memory, then memory is not exclusive to living systems. It becomes a property of time itself. This is where the assumption hidden inside the Big Bang becomes impossible to ignore. We assume that time has no texture, no tension, no capacity to store information beyond sequence. But what if time, like any medium, carries scars? What if each cycle leaves faint traces, not readable as events, but readable as constraints? Boundaries within which future evolution must unfold? In such a universe, laws would appear constant not because they are eternal, but because they are reinforced by repetition. Each cycle nudges the system back toward familiar behaviors. Physics would not be written once. It would be rehearsed, and rehearsed systems grow stable. This would mean that what we call fundamental constants might not be fundamental at all. They could be attractors, values the universe returns to each time it breathes. Slightly different each cycle, close enough to feel identical from the inside. If that were true, then our current measurements are not snapshots of an absolute reality. They are mid-breath readings, which raises a deeper unease. Because if we are not at the beginning of time, then the universe has existed long before anything we can observe. And if it will continue breathing long after this phase ends, then nothing we call permanent truly is. Not expansion, not stability, not even the laws themselves, only rhythm persists. And rhythm implies something else, something that sits quietly beneath all oscillations. A restoring tendency, something that pulls the universe back when it stretches too far, something that releases it when it tightens too much. Not a force in space, but a constraint in time. We do not have a name for this yet. We do not have equations for it. All we have are hints that the universe resists extremes in ways that pure expansion does not naturally explain. And once that resistance is acknowledged, the Big Bang stops being the loudest idea in the room. It becomes one note in a much longer composition, which leaves us with a question that cannot be postponed any longer. If the universe is cycling through phases, and if time itself carries the rhythm of those phases, then what exactly happens at the deepest part of the cycle when time is most compressed and the universe is holding its breath? Because whatever occurs, there would shape everything that follows. We are not built to sense slow things. Our instincts are tuned to movement that happens faster than memory fades. A predator lunges, a storm forms, a sound echoes, then disappears. We recognize change because it arrives before we forget what came before it. But the universe does not move on human scales. It moves on scales where entire species blink in and out between two almost identical moments. It moves so slowly that change disguises itself as permanence. And that is why a breathing universe would be almost impossible to notice from the inside. If the universe oscillates, not rapidly, not violently, but across spans of billions or trillions of years, then every observer trapped inside a single slope of that oscillation would report the same thing. Nothing is changing. Everything is stable. The direction is obvious. From inside a slow inhale, expansion looks eternal, not because it is, but because the curve is too wide to perceive. Imagine standing on the side of a mountain so vast that its slope appears flat. You could walk for generations without realizing you were climbing. Every measurement you take confirms your belief. The ground is level. The horizon does not tilt. Gravity behaves as expected. And yet, far beyond your ability to see, the peak exists. This is how oscillations hide. They do not need to be invisible. They only need to be slow. If the universe breathes, then its oscillation period would dwarf anything we can directly observe. The rise and fall of entire cosmic epochs would register to us as linear trends, steady expansion, steady cooling, steady dilution. But linearity is what curves look like when you zoom in too far. This matters because nearly every conclusion we draw about the fate of the universe is extrapolated from a tiny slice of its motion. We see galaxies moving away. We see acceleration. We project that behavior forward indefinitely. But projection assumes continuity. It assumes that the present phase continues uninterrupted, unchanged, unopposed. A breathing universe violates that assumption quietly. It introduces turning points so distant that no current observation can detect their approach. It allows for reversal without warning, because warning itself requires perspective. And perspective is precisely what we lack. Our cosmic history, all 13.8 billion years of it, may represent less than 1% of a single oscillation, possibly far less, a shallow arc mistaken for a straight line. This reframes a question we rarely dare to ask. How do we know the universe is not slowing down in a way that mimics acceleration? Acceleration itself is not directly observed. It is inferred. We compare redshifts at different distances, fit curves, and interpret the trend. But trends are sensitive to assumptions about the underlying clock. If the clock itself is changing pace, then the curve bends for reasons unrelated to motion. Time thickening would produce exactly this illusion. As time stretches, each successive interval contains more duration. Light emitted later experiences a different temporal environment than light emitted earlier. When those signals are compared, the difference accumulates. To an observer assuming a constant clock, it looks like acceleration. But acceleration of what? Of space? Or of time's looseness? In a breathing universe, the answer is neither simple nor singular. The oscillation would not require space to stop expanding and reverse violently. It could reverse gently, imperceptibly, over spans longer than stars can survive. There would be no cosmic alarm, no moment where expansion halts abruptly, only a gradual shift in the balance between temporal stretch and compression. At the deepest inhale, time would be most diffuse. Moments would be longest. Processes would slow. Change would feel rare. Stability would dominate. This could explain something that otherwise feels coincidental. Why the universe seems unusually calm on large scales. Why violent events are local rather than global. Why large-scale structures persist for billions of years. Why chaos never quite overruns order. A system near the apex of an inhale resists rapid change. Everything has room. Everything is spaced out. Nothing presses too hard against anything else. Expansion, in this view, is not destruction, it is relief. But relief cannot last forever. Every oscillatory system carries within it the conditions for its own reversal. Not because of external force, but because extremes are unstable. A breath held too long demands release. Which brings us to the uncomfortable part. If the universe is near the peak of an inhale, not at the beginning, not at the end, but somewhere in the long middle, then acceleration does not mean escape. It means approach. Approach toward a turning point so distant that its existence feels theoretical rather than real. But theoretical does not mean irrelevant. because the mere presence of a turning point changes the interpretation of everything before it. The future of the universe, in this view, is not endless thinning. It is not heat death, stretched infinitely forward. It is transition, and transition has consequences that ripple backward in meaning, even if not in causality. Entropy, for example. We are taught that entropy always increases, that disorder grows, that usable energy declines irreversibly. This is treated as absolute, universal, unquestionable. But entropy is defined relative to time's arrow. If time breathes, if its pace changes, then entropy's behavior may not be as monotonic as we assume. It may increase differently in different phases. It may saturate. It may redistribute rather than simply accumulate. A compressed temporal phase could amplify order. A diffuse phase could allow disorder to spread. Entropy might not reset, but it might cycle within bounds. This would mean that the universe does not march toward a cold end. It drifts toward balance, overshoots slightly, then drifts back. Not immortality, but endurance. And endurance leaves signatures that look suspiciously like fine-tuning when misinterpreted. The delicate balance between expansion and gravity. The narrow range of constants that allow complexity. The long-lived stability of physical laws. These may not be lucky accidents. They may be the natural outcome of a system that has passed through many breaths, smoothing itself with each cycle. A universe that has oscillated before would arrive at each new phase already trained, which raises a question that destabilizes the way we think about beginnings. If the universe has breathed before, then our current phase inherited conditions from a previous one. Conditions shaped not by chance but by constraint. The Big Bang, then, is not a blank slate. It is a handoff. Information does not need to survive in recognizable forms. It does not need memory as we understand it. It only needs tendencies, limits, gradients, preferences, encoded into the structure of time itself. A universe that breathes does not forget everything when it turns around. It forgets violently changing details. It retains deep structure. This is why oscillatory models are so unsettling. They do not merely add a phase before the Big Bang. They suggest that the universe has a history deeper than observation, deeper than measurement, deeper than narrative. And history without witnesses feels uncomfortable to a species that defines reality by observation. Because if the universe has been breathing for cycles longer than consciousness has existed, then meaning is no longer tied to being first. It is tied to being part of the rhythm, which reframes our position again. We are not late. We are not early. We are mid-breath. And mid-breath is deceptive. Everything feels stable. Everything feels directional. Everything feels like it will continue as it has. But every breath contains its own reversal. The question is not whether the universe will turn around. The question is how such a turn would announce itself, if at all, to observers embedded inside the fabric of time it is rearranging. Because a turning point in time's elasticity would not look like collapse at first. It would look like subtle resistance, processes slowing where they should speed up, rates flattening where they should steepen, patterns deviating gently, persistently, without obvious cause. And this is where the next layer of the problem begins to emerge. If the universe is approaching or has passed a temporal inflection point, then certain signals would begin to behave strangely, not catastrophically, not dramatically, just enough to create tension between models that should agree. And that tension would not announce itself as breathing. It would announce itself as disagreement, which means the next place to look is not at galaxies or backgrounds or grand narratives. It is at the cracks. The places where measurements refuse to align. The places where different methods produce slightly different answers for the same cosmic quantity. Because if time is not uniform across the universe, then disagreement is not noise. It is the signal we have been ignoring. And that is exactly where the next question is waiting. There is a moment in every scientific story where confidence begins to fray. Not loudly, not with contradiction, but with disagreement. Two measurements, same universe, same laws, different answers. At first, this feels ordinary. Instruments improve, methods refine, error bars shrink. Discrepancies are expected temporary imperfections on the way to convergence. But sometimes, convergence does not come. Sometimes, the disagreement hardens, and when it does, science gives it a name that sounds harmless enough: attention. The word suggests stress, not failure. Something stretched, but not broken. A signal that a system is being pulled in two directions at once. Cosmology is full of such tensions. The most famous is the Hubble tension, a disagreement about how fast the universe is expanding. One method looks at the early universe, reading the faint glow left behind when everything was hotter and denser. Another looks at the local universe, measuring distances to stars and galaxies much closer to home. They should agree? They do not. The difference is not small. It is persistent, and no amount of calibration has erased it. We usually treat this as a technical problem. Perhaps the early universe models are incomplete. Perhaps local measurements hide systematic errors. Perhaps new particles or forces are involved. All reasonable possibilities. But notice what none of these explanations question. They do not question time. Both sides of the disagreement assume that time flows uniformly across the cosmos. They differ on parameters, not on the medium itself. They argue about what the universe is doing, not about what time is doing while it does it. A breathing universe reframes this tension immediately. Because if time itself is not uniform, if its elasticity changes across cosmic history, then the disagreement is not an error. It is expected. Measurements that rely on early time signals would be anchored to a different temporal regime than measurements made locally. The clocks embedded in those signals would not tick at the same pace as the clocks we use now. And when you force them to agree, something has to give. This is the first crack where the breathing hypothesis presses through, because the Hubble tension is not about distance alone. It is about how time accumulates between emission and observation. Early universe methods infer expansion by reading patterns frozen into radiation when the universe was young. Those patterns encode assumptions about how time behaved during that era. Local methods measure distances by calibrating standard candle stars whose brightness we believe we understand. Both rely on time. Both assume its uniformity. If that assumption is even slightly wrong, the disagreement becomes inevitable. And the universe does not rush to correct it. It lets the tension sit there, unresolved, persistent, uncomfortable. There are other cracks. The so-called sigma-8 tension disagreements about how clumpy matter should be versus how clumpy it appears to be. Models predict a universe slightly more structured than what we observe. Again, the discrepancy is subtle, not enough to declare failure, too large to ignore. We usually explain this by tweaking dark matter behavior or introducing new physics. But clumpiness is a time-sensitive property. Structures grow as time passes. They collapse, merge, and settle according to how long gravity has had to work. If time stretches differently across epochs, then growth rates inferred from early conditions will not match growth observed locally. The universe would look underdeveloped not because gravity is weak, but because time was thinner when structure formation mattered most. A breathing universe does not distribute time evenly. It allocates it. Some phases give matter more opportunity to organize. Others dilute opportunity by stretching intervals. From inside a single phase, this looks like a mismatch between prediction and reality. Another crack appears in the cosmic microwave background itself. The background radiation is astonishingly uniform, yet it carries tiny fluctuations, seeds of all future structure. These fluctuations align with models beautifully, almost too beautifully, but not perfectly. There are anomalies, large-scale asymmetries, slight temperature variations that refuse to average out, patterns that appear aligned in ways they should not be. We often dismiss these as statistical flukes, but statistics are shaped by assumptions. If the universe passed through previous cycles, then large-scale correlations may be inherited rather than random. The background radiation would not be a clean slate, it would be a palimpsest. Faint traces from before the last transition. Not messages, not information in any deliberate sense, just tendencies. A breathing universe would not erase everything, when it changes direction. It would smooth violently unstable features. It would preserve deeply embedded ones, which means anomalies at the largest scales are exactly where memory would hide. And memory is uncomfortable because it implies continuity. Continuity across what we call the beginning. This is why oscillatory ideas are so often pushed aside. Not because they fail mathematically, but because they fail narratively. They do not give us a clean origin. They do not let us declare a moment of creation. They suggest the universe existed before anything we can see. And science, like storytelling, prefers beginnings. But the cracks do not care about preference. They persist whether we like them or not. Another tension lies in dark energy itself. We treat it as a constant, a smooth, uniform energy density filling space. But observations allow it to vary slightly over time. Not enough to force a revision, enough to raise eyebrows. If dark energy is really a manifestation of time's elasticity, then variation is not a problem. It is a signature. An inhale is not perfectly uniform. It accelerates toward its peak. It decelerates after. Dark energy behaving like a constant would be surprising in a breathing universe. Dark energy behaving almost like a constant is exactly what you would expect. Enough stability to confuse us, enough drift to keep the cracks open. And this pattern repeats. Everywhere, cosmology assumes uniformity. Small disagreements emerge. Not large enough to overturn the framework. Not small enough to disappear. As if the universe is quietly refusing to let the model close. This is what makes the breathing hypothesis difficult to dismiss. It does not predict dramatic new phenomena. It predicts subtle misalignments. It predicts a universe that almost fits our expectations and then doesn't, just enough to remain unresolved. And unresolved tension is the hallmark of a deeper assumption waiting to be challenged. Because when independent measurements disagree persistently, there are only three possibilities. The data is wrong, the models are incomplete, or the foundation is flawed. We have spent decades refining instruments. The data keeps improving. The tensions remain. We have expanded models, added parameters, introduced new components. The tensions soften, then reappear elsewhere, which leaves the foundation, time. The one thing we rarely question, because questioning it feels destabilizing. If time itself is allowed to vary, many problems stop being problems. They become features. But this introduces a deeper discomfort, because if time is elastic, then chronology is local. The order of events remains intact, but their pacing does not. What we call early and late becomes relative to phase, not absolute position in a universal timeline. The universe would not have a single age. It would have a distribution of ages. And light, passing through this distribution, would integrate those differences into the signals we observe. This would mean that cosmology is not wrong. It is averaged. An average description of a system whose internal rhythm we have not yet resolved. And averages hide dynamics. They smooth cycles into trends. They turn oscillations into slopes. They turn breathing into expansion. The cracks are where the averaging fails, where different parts of the universe refuse to agree on what time has done to them, which means the next step is not to look farther away. It is to look closer at time itself. Not as a coordinate, not as a parameter, but as a physical medium whose properties may change across cosmic history. If time can stretch enough to create redshift, if it can vary enough to produce persistent tensions, then it must have structure. And structure implies rules. Rules that govern how time thickens and thins. Rules that determine when a phase ends and another begins. Rules that would be invisible until the universe approaches a turning point. And that brings us to the most unsettling possibility yet. If the universe is breathing, and if the current tensions are early symptoms of temporal strain, then the disagreement we see today may not be noise from the past. It may be pressure from the future. And understanding that pressure requires us to ask a question that physics has avoided for a very long time. What does time do when it is pushed too far? Because whatever the answer is, it will not remain theoretical forever. Time is usually defined by what it is not. It is not space. It is not matter. It is not energy. It is the backdrop against which everything else exists. or so we are taught. But every time physics has treated something as a backdrop, it has eventually been forced to admit that the backdrop participates. Space was once thought to be empty, then it bent. Vacuum was once thought to be nothing, then it fluctuated. Even nothing turned out to have structure. Time may be next, because the moment we stop treating time as an abstract parameter and start asking what it does, the universe begins to look very different. Time, after all, already behaves like a medium. It stretches near mass. It slows with velocity. It disagrees with itself when observed from different frames. These are not metaphors. They are measurements. Clocks in orbit tick faster than clocks on Earth. Clocks on fast-moving satellites drift from those at rest. Time already bends, we just refuse to let it breathe. What we call time dilation is treated as an effect, not a property. A response to motion or gravity, not an intrinsic behavior. But a breathing universe asks us to reverse that logic. What if time dilates not only because of local conditions, but because of global phases? What if the universe periodically enters states where time itself becomes more diffuse, where intervals lengthen everywhere, slowly, coherently, without any single mass or motion causing it? In that case, time is no longer just reacting. It is acting. And action implies dynamics. Dynamics imply limits. And limits imply turning points. This is where time begins to resemble something familiar, a fluid, not flowing through space, but flowing through itself, thickening in some epochs, thinning in others, carrying signals, memory, and constraint the way any medium does. If time is fluid-like, then redshift is not just a geometric effect. It is a viscous one. Light traveling through thicker time would lose energy the way a wave loses amplitude moving through denser material, not abruptly, gradually, cumulatively. To an observer, assuming a vacuum, it looks like stretching. But the cause is resistance. Not resistance to motion, resistance to persistence. And this reframes a core assumption. We assume that a photon does not age, that it experiences no passage of time, that it moves at a constant speed regardless of context. But these statements are only true locally. Globally, a photon's journey is not just about speed, it is about endurance. If time itself becomes more viscous across cosmic history, then a photon's frequency will shift even if its velocity does not. Energy loss without friction, change without collision, aging without experience. This is unsettling because it suggests that time can drain energy without interacting in the usual sense. But we already accept this idea in another domain, entropy. Entropy drains usable energy from systems without violating conservation. It does not destroy energy. It redistributes it into less accessible forms. A breathing time would behave similarly. Energy would remain conserved globally, but locally degraded in ways that depend on temporal phase. Expansion would not be driven by force. Cooling would not be driven by escape. Both would be driven by dilution in time. This explains why expansion appears uniform. A global change in time's elasticity would affect everything equally, regardless of direction. No center required, no edge implied. The universe would not be expanding into anything. It would be loosening within itself. And loosening has consequences. Processes slow. Interactions weaken. Structures become harder to form. Which brings us back to something we usually attribute to coincidence. Why did complexity arise when it did? Stars, galaxies, chemistry, life, all emerging during a narrow window of cosmic history. Too early, and the universe was too hot. Too late, and it is too diffuse. In a breathing universe, this window is not accidental. It is the overlap between sufficient density and sufficient temporal thickness. Too compressed, and processes run too fast, too violently, leaving no room for stability. Too diffuse, and processes slow so much that organization becomes improbable. Life emerges when time has just the right texture, not too tight, not too loose, which suggests something quietly radical. The habitability of the universe may be a temporal phenomenon, not a spatial one. We search for life by looking for the right distances from stars, the right chemical compositions, the right temperatures. But if time breathes, then entire epochs may be more or less hospitable regardless of location. There may be eras where complexity is easy everywhere, and eras where it is difficult everywhere. We may be living in such an era now, which makes our moment feel less accidental and more conditional. But conditions change. A breathing universe does not hold any phase indefinitely. As time continues to loosen, processes that rely on precise timing begin to falter. Nuclear reactions slow. Star formation declines. Structures drift apart not because gravity weakens, but because the temporal medium no longer supports tight coupling. Eventually, the inhale reaches its limit. Time becomes as diffuse as it can be without tearing causal structure apart. At that point, something must change. Not violently, not suddenly, but necessarily, because no oscillatory system remains at an extreme forever. The question is not whether time will tighten again. The question is how tightening begins. Does it start everywhere at once? Does it propagate like a wave? Does it require a trigger? Or is it intrinsic? We do not know, but we can infer something important. A tightening of time would not announce itself as collapse. At first, it would look like resistance. Rates would stop declining. Processes would stabilize. Acceleration would plateau. The universe would appear to hesitate. And hesitation is subtle. It would show up as stubborn discrepancies, as models that almost fit, but not quite, as measurements that refuse to converge, which is exactly what we see. This is why treating time as a medium matters, because once time is allowed to have properties, the universe stops looking like a runaway system and starts looking like a regulated one. Not regulated by intelligence, not regulated by intention, regulated by structure. Structure that exists whether we describe it or not. But structure also implies vulnerability. If time has elasticity, it has limits. If it has limits, it can be strained. If it can be strained, it can fail or transform. And transformation is where the deepest mysteries hide. Because whatever happens when time reaches its extremes would determine the fate of everything built upon it. Matter, energy, causality, memory. All of it depends on time behaving within a narrow range. Which means the most important question is no longer about space. It is about endurance. How much can time stretch before it must respond? And what does that response look like from the inside to observers who can only measure its effects, never its cause? Because if time is beginning to resist further stretching, then the universe may already be closer to its turning point than our narratives allow. And that realization does not end the story. It shifts it toward the moment where breathing is no longer metaphor but mechanism. And that moment demands we examine what happens when time is pushed to its limit. The universe has a memory, not a memory that thinks, not a memory that chooses, but a memory that remains. We usually call it background, a faint microwave glow bathing the sky from every direction. So uniform, so cold, so unassuming, that it feels almost forgettable. It hums quietly at just a few degrees above absolute zero, filling the cosmos with a relic of something long past. This glow is one of the strongest pillars of modern cosmology. It is said to be the afterglow of the Big Bang light released when the universe cooled enough for atoms to form, when matter and radiation finally parted ways, when photons were set free to travel forever. The story is elegant, mathematically precise, reassuring in its clarity. And yet, like redshift, the background radiation only tells us that something happened, not what kind of thing it was. It is a fossil. But fossils do not tell us whether an animal died suddenly or slowly. They only tell us that it once existed. The cosmic microwave background does not tell us whether it was born in an explosion or released in a transition. This distinction matters, because in a breathing universe, the background radiation would not be an afterglow of creation. It would be something subtler, a residue, a thermal imprint left behind when the universe passed through a denser, tighter phase of its cycle, when time itself was compressed enough that energy could not help but remain coupled to matter. In such a phase, light would not be free. It would be trapped, not by walls, not by force, but by proximity. Moments would be short, intervals tight, interactions unavoidable. Photons would scatter endlessly, unable to escape the grip of matter because time itself would not allow clean separation. Then, as the universe began to inhale, as time loosened, something would happen. Not an explosion, a release. At a certain threshold, the temporal medium would become permissive enough for light to decouple. Photons would stop colliding constantly. They would begin to travel, not because space suddenly expanded violently, but because time finally gave them room. The moment we call recombination in standard cosmology could be reinterpreted as something more fundamental. The moment when time crossed a critical elasticity. Before it, everything was crowded in time. After it, persistence became possible. Light did not escape space. It escaped compression. And the glow we see today would be the thermal memory of that release. A frozen breath. This idea reframes the remarkable uniformity of the background radiation. In the Big Bang narrative, uniformity is explained by inflation, a rapid expansion that smoothed everything out before structure could form. It works, but at the cost of introducing an extra phase whose purpose is primarily corrective. A breathing universe would not require correction. Uniformity would be the natural outcome of a compressed temporal phase. When time is tight, differences cannot grow. Fluctuations are suppressed. Irregularities are averaged out. Local variations are erased by relentless interaction. A compressed time phase acts like a cosmic blender. Everything mixes, which means when the universe begins to loosen again, it emerges already smoothed, not because it was forced to smooth itself, but because it could not do otherwise. This also reframes the tiny fluctuations we do see in the background radiation. Those minute temperature variations, 1 part in 100,000, are treated as seeds of structure. Random quantum fluctuations stretched to cosmic scales. But randomness is not the only way to generate variation. Residual tension can do the same. If the universe passed through multiple breathing cycles, then the compressed phase preceding our current inhale may not have been perfectly symmetrical. Slight anisotropies could survive not as detailed memories, but as gentle biases. Preferences. These would not encode events. They would encode tendencies. And tendencies are exactly what we see. Large-scale alignments, unexpected correlations, anomalies that appear at the biggest scales and vanish at smaller ones. These are difficult to explain with local physics. But they make sense if the background radiation carries information from before the last transition, not as history, but as constraint. The universe did not start from nothing. It started from something that had already been shaped, which is why the background radiation feels so eerie when you think about it deeply. It is not just old. It is ancient in a way that predates narrative. It is older than stars, older than galaxies, older than chemistry, but it may not be older than the universe itself. It may be the universe remembering itself. And memory, once allowed, changes everything. Because memory implies continuity. Continuity across what we call the beginning. If the background radiation is a frozen breath, then it is evidence that the universe has breathed before, that it has tightened, released, and tightened again. The Big Bang becomes not a birth certificate, but a timestamp, a marker of the last major transition in time's elasticity. And this solves another quiet puzzle. Why does the background radiation have a temperature at all? If it were simply the diluted remnant of an explosion, one might expect its energy to disperse endlessly. But instead, it cools predictably, maintaining a coherent spectrum. In a breathing universe, this coherence is natural. Thermal memory would be preserved by the same temporal structure that governs redshift. As time stretches, energy dilutes smoothly, not chaotically. The background radiation cools because time loosens, not because it is running away. And this interpretation changes the way we think about cosmic silence. We often imagine the early universe as loud, hot, dense, violent, and the current universe as quiet and empty. But a breathing universe suggests a different contrast. The early universe was tight. Interactions were unavoidable. Persistence was rare. Everything happened quickly. The current universe is spacious in time. Processes take longer. Structures endure. Change feels slow. Noise fades not because energy vanished, but because time allows separation. which means silence is not emptiness. It is permission, and permission has limits. A temporal medium that loosens too far eventually undermines the very structures it allowed to form. Stars burn out. Galaxies drift apart. Interactions become too rare to sustain complexity. This is the other side of the inhale. Relief becomes dilution, which brings us to a crucial realization. The cosmic microwave background does not just tell us where the universe came from. It tells us what kind of phase allowed it to become structured at all. And if that phase was part of a cycle, then future phases will not resemble the present. The universe will not simply cool forever. It will change mode. At some point, time will begin to tighten again. Not suddenly, not catastrophically, but inevitably. And when that happens, the background radiation will no longer be the oldest thing we can see. It will become a reference point, a reminder of how the universe behaves when time changes its grip, which raises a question that has been quietly forming beneath everything we have discussed. If time compression leaves behind a thermal memory, then what else does it leave behind? Because energy is not the only thing that responds to temporal density. Information does too. And if information can survive transitions in compressed form, then the universe may carry more from its past than we have ever allowed ourselves to imagine. That possibility does not live in radiation. It lives in structure, in the way matter organizes, in the way laws remain stable, in the way complexity arises again and again, which means the next place we must look is not at light, but at how information behaves when time itself breathes. Because if the universe remembers, it does not remember in pictures. It remembers in patterns. And patterns are where the next layer of the story waits. We tend to imagine ourselves as late arrivals, born long after the universe began, appearing near the quiet end of a long story, living in the fading light of something that has already done most of its work. This feeling is subtle but persistent. It shapes how we interpret the sky. We look outward and see exhaustion, stars burning out, galaxies drifting apart, energy thinning into silence. It feels like aftermath. But that feeling depends entirely on one assumption, that what we are seeing is the end of a process, not the middle of one. A breathing universe dissolves that assumption quietly, because if the universe oscillates, then there is no privileged late. There is only position within a cycle, and position is deceptive when the cycle is vast. From inside a single inhale, everything looks like decline after birth. From inside an exhale, everything looks like collapse after expansion. From inside a pause, everything looks frozen. We are not late. We are located. And our location may be far more central than we realize. Consider the scale of a single cosmic breath. If one full cycle inhale, pause, exhale, pause spans tens or hundreds of billions of years, then the entire history of stars, galaxies, and life could unfold within a narrow band of that cycle. A region where time is neither too compressed nor too diffuse. A region where persistence is possible. We often talk about the universe being young enough for stars to form, or old enough for heavy elements to exist. These are framed as lucky coincidences, but in a breathing universe, they are phase effects. Stars form when time has enough room to allow long chains of interaction, but not so much room that matter rarely meets itself. Chemistry becomes rich when reactions have time to occur, but not so much time that reactants drift apart before colliding. Life emerges when the tempo of time is slow enough to allow complexity, but fast enough to allow change. This is not chance, it is timing, which means that intelligent observers like us are not simply passengers in the universe. We are indicators. Our existence tells us something about where we are in the cycle. Not near the tightest compression, life could not survive there. Not near the most diffuse expansion, life could not organize there. But somewhere in between, inside the smallest viable inhale. This idea reframes the so-called cosmic coincidence problem. Why do we exist at a time when dark energy and matter densities are comparable? Why now, and not much earlier or much later? In a standard expanding universe, this feels improbable. A brief overlap between two curves with no obvious reason to intersect near our era. In a breathing universe, it is expected. The overlap corresponds to the phase where time's elasticity supports both persistence and change, where structures are stable enough to endure, yet dynamic enough to evolve. Observers arise during that overlap because only during that overlap can observers arise. This is not anthropic reasoning as an excuse. It is anthropic reasoning as a diagnostic. We are not special because the universe is tuned for us. We are present because the universe is in a tunable phase, which means our observations are biased in a very specific way. We see a universe that looks stable because instability lies outside our viable window. We see a universe that looks directional because reversal lies far beyond our temporal horizon. We see expansion because contraction is not yet observable from our position. This does not make our measurements wrong. It makes them partial, and partial views are dangerous when mistaken for complete ones. From our vantage point, the universe looks as though it has been expanding forever and will continue to do so. But this is exactly what any observer embedded mid-inhale would conclude. No civilization could arise early enough to see the release from compression. No civilization could persist long enough to witness the full turnaround. All observers exist during the gentle slopes, which means every observer thinks their phase is the rule, not the exception. This creates a deep illusion, the illusion that the universe has a preferred direction. But direction is only meaningful when cycles are invisible. This is why cosmological narratives often sound final. Heat death, eternal expansion, ultimate silence. They extrapolate from a local slope to an infinite future. But extrapolation fails in oscillatory systems. A pendulum observed for a few seconds looks like it is moving in one direction. A breath observed mid-inhale looks like endless expansion. Only a full cycle reveals truth. And we do not have access to a full cycle. We are inside it. This realization changes the emotional tone of cosmology. Instead of living at the end of a long decline, we may be living near the most spacious, most permissive region of time. A crest where complexity flourishes precisely because time has loosened enough to allow it. Not the end, the opening. But openings are fragile. They depend on balance. Too much looseness and interactions fade. Too much compression and everything collides too fast. Life exists on the edge between these extremes, which means the universe does not just breathe, it regulates. And regulation implies feedback. Somehow, the universe maintains a rhythm that repeatedly passes through habitable phases without collapsing into monotony or chaos. That rhythm does not need intention. It only needs structure, the same structure that produces stars, the same structure that produces chemistry, the same structure that produces observers. This raises a subtle but powerful question. If observers arise only in certain phases, then the universe is never fully observed. Its extremes are unmeasured. No one is there to see the deepest compression. No one is there to witness the most diffuse expansion. The universe's most dramatic moments are unwitnessed, which means our entire cosmological record is drawn from a narrow slice of possibility. We are reconstructing the whole from the most comfortable part. This is not a flaw. It is a constraint. And constraints shape theory. They explain why certain ideas feel intuitive and others feel impossible. Why beginnings are easier to imagine than cycles. Why endings feel more real than reversals. Our minds evolved inside a window. That window colors everything, even our mathematics. When we write equations, we assume continuity because continuity is what we experience. We assume monotonicity because reversal lies outside our observation. We assume linear time because cycles are too slow to reveal curvature. A breathing universe violates these intuitions quietly. It does not break causality. It does not undo physics. It simply stretches the context. And stretching context changes meaning. Expansion becomes one half of emotion. Acceleration becomes a sign of approaching transition. Stability becomes a temporary balance. And life, including our own, becomes a phase-dependent phenomenon. We are not witnesses to the universe's beginning. We are participants in its rhythm. This realization should make us cautious, because if our existence depends on a particular temporal texture, then changes in that texture will matter more than changes in space. Stars can still exist while life vanishes. Galaxies can still persist while chemistry fails. Space can remain vast, while time becomes inhospitable. The fate of complexity is not tied to size. It is tied to tempo, which means the most important question is no longer, how big will the universe get? It is, how will time change? And that question cannot be answered by looking only at expansion rates or distances. It requires understanding how temporal elasticity evolves across phases. It requires understanding what happens as the inhale approaches its limit. Because at some point, time cannot loosen further without undermining the structures it supports. At that point, something must respond. Not space, not matter, time itself. And when time responds, the universe will not announce it with fireworks. It will announce it with subtle shifts in what is possible. Processes that once worked will fail. Interactions that once occurred will rarefy. Patterns that once repeated will drift. And those shifts will not look like catastrophe. They will look like inconvenience, which is far more dangerous. Because civilizations do not prepare for inconvenience. They prepare for disaster. And this is why understanding where we are in the breath matters. Not for prediction, not for control, but for perspective. Because perspective determines what we notice. And what we are currently noticing, tensions, anomalies, mismatches, may not be signs of error. They may be signs of position, signs that we are not at the beginning of the inhale anymore. And that realization pulls us toward the next layer of the story. If observers exist only within a narrow temporal window, then the laws they observe may also be window-dependent, not false. Contextual, which means the next question cannot be avoided. Are the laws of physics themselves fixed across the entire breath, or do they, too, participate in the rhythm? Because if laws are stable only within phases, then what we call fundamental may be far more fragile than we have ever admitted. And that possibility waits just ahead, where time and law begin to blur into one another. We speak of physical laws as if they were carved into stone. Constants are constant. Rules are universal. Equations apply everywhere, always, without exception. This belief sits at the foundation of modern science. It gives us confidence that what we discover here applies there. That what works now worked before. That the universe plays by the same rules no matter when or where we look. But this confidence rests on a quiet assumption that the medium those laws are written into never changes. If time itself breathes, that assumption becomes fragile. Because laws do not exist in isolation. They are not floating abstractions. They are relationships between quantities, behaviors, and constraints, all of which depend on the structure of time. Change the structure, and the relationships may still hold, but only locally. Consider something deceptively simple, the speed of light. We treat it as a universal constant, measured, confirmed, built into the geometry of space-time itself. And yet, what we really measure is the ratio between distance and time. If time stretches, that ratio remains the same locally. Light still moves at the same speed relative to nearby clocks and rulers. But globally, over epochs where time's elasticity shifts, the meaning of speed becomes subtle. A photon emitted when time is tighter and observed when time is looser will arrive redshifted even if its local speed never changed. The law holds. The interpretation drifts. This is the pattern that begins to emerge. Laws remain intact within a phase. Their consequences change across phases, which means that when we say the laws of physics are universal, we may be committing a category error. They may be phase universal, not time absolute, stable within breaths, not necessarily identical across them. This is unsettling because it reframes one of the deepest assumptions in science, that the universe is governed by timeless rules. But timelessness is a human preference. We seek permanence because we live briefly. We anchor meaning to what does not change because everything else does. The universe may not share that preference. In a breathing cosmos, laws would emerge as attractors, patterns that reassert themselves cycle after cycle, not because they are eternal, but because the system returns to conditions where those patterns are favored. Like standing waves on a vibrating string, the string moves, the vibration continues, the pattern persists. not because it is fixed, but because it is stable. This would explain why fundamental constants appear so finely tuned, why small changes would collapse complexity, why values cluster around narrow ranges. These may not be arbitrary numbers selected at the beginning of time. They may be equilibrium points, values the universe naturally drifts toward during each breath because departures are self-correcting. Too much deviation and structure fails. Structure failure reduces complexity. Reduced complexity alters feedback. The system settles back. Not instantly, not deliberately, but inevitably. This view dissolves the mystery of fine-tuning without invoking intention or multiverses. It replaces selection with recurrence. The universe is not lucky. It is rehearsed. Each cycle reinforces the same constraints, carving grooves into the fabric of time itself. Laws feel eternal because they have survived many breaths. But survival is not the same as immutability. If laws are phase-stable rather than absolute, then they may drift slightly at transitions. Not enough to break causality. Not enough to shatter continuity. Enough to change what is possible. This opens a door we rarely look through. What if some of the deepest puzzles in physics arise, not because we lack particles or forces, but because we are trying to force phase-specific laws into a timeless frame? Take quantum mechanics. Its probabilistic nature has always felt alien compared to the smooth determinism of classical physics. We reconcile them awkwardly, stitching two descriptions together and hoping the seam holds. But what if quantum behavior reflects a deeper truth about time's texture? In compressed, temporal phases, uncertainty may be unavoidable. Events overlap. Interactions blur. Distinction loses meaning. Probabilities dominate, because time does not allow clean separation. As time loosens, classical behavior emerges. Processes stretch out. Cause and effect become distinct. Determinism appears. Quantum and classical may not be rival descriptions. They may be phase expressions, different faces of the same system under different temporal conditions. This would explain why quantum behavior dominates at small scales and early epochs, while classical behavior governs large structures and later times. Not because size determines law, but because time density does. Small scales experience effective compression. Large scales experience effective diffusion. Again, the law holds locally. Its expression changes with context. General relativity tells a similar story. Gravity is geometry. Matter tells spacetime how to curve. Spacetime tells matter how to move. But spacetime includes time. If time's elasticity changes globally, then curvature does not mean the same thing everywhere or everywhen. A breathing time would subtly modulate how gravity operates over cosmic history, not by changing equations, but by changing what those equations act upon. Gravity might appear stronger or weaker in different epochs, not because the force changes, but because time's response to curvature changes. This could leave fingerprints, unexpected galaxy rotation curves, structure formation that proceeds too fast or too slow, gravitational effects that require invisible components to explain. We call these dark matter. But what if some portion of what we attribute to unseen mass is actually the shadow of temporal behavior we have not modeled? Not all of it. Not enough to discard dark matter. Enough to complicate the picture. This is the danger of assuming timeless laws in a breathing universe. You begin assigning new entities to explain effects that arise from context. You add components when the medium itself is changing. This does not mean cosmology is wrong. It means it is overfitted. Which brings us back to a recurring theme. The universe keeps behaving almost as expected. Almost, and almost is where breathing hides. If laws were radically different across phases, the universe would be unrecognizable. Continuity would break. Memory would vanish. Complexity could not recur. But if laws drift only at the margins subtly, slowly, reversibly, then continuity is preserved while context shifts. This is exactly the behavior of oscillatory systems. They retain identity across cycles while changing state. The same string vibrates. The same pendulum swings. The same universe breathes. Which means the deepest laws may not be equations. They may be constraints, boundaries on how far time can stretch, limits on how tight compression can become, thresholds where phase transitions occur. Within those boundaries, familiar laws emerge. Outside them, new regimes appear. And the boundaries themselves are not written in space. They are written in time. This idea reframes the concept of fundamental. Fundamental may not mean unchanging. It may mean resilient. The laws we observe may be the ones that survive repeated breathing, not because they are perfect, because they are stable. This also reframes the question of predictability. If laws are phase stable, then prediction works best within phases and degrades near transitions. The closer a system approaches a turning point, the less reliable extrapolation becomes. This is not chaos. It is context loss. And context loss would manifest exactly as we see it now. Models that fit well in one regime and poorly in another. Parameters that drift slightly without explanation. Predictions that work locally and strain globally. The universe is not refusing to be understood. It is reminding us that understanding has boundaries. Boundaries defined not by ignorance, but by position within a cycle. Which brings us to a subtle but profound implication. If laws are stable only within breaths, then the deepest transformations of the universe do not violate physics. They transcend the phase in which physics was formulated. A breathing universe does not need new laws to turn around. It only needs to exit the regime where the old ones apply cleanly. And that is where the most dramatic changes occur. Not at singularities, not at infinities, but at thresholds, moments where time's elasticity reaches a limit and the system must reorganize. These thresholds would not be visible as events. They would be visible as ambiguity, as a breakdown of clear categories, as a blurring between regimes, as confusion about what applies where. And if we are approaching such a threshold, or even drifting closer to it, then the discomfort we feel in modern physics is not accidental. It is anticipatory. We are sensing the edge of a phase with tools designed for the middle, which means the next step is not to add more complexity. It is to ask a simpler question. What happens to information when laws themselves are phase-bound? Because if laws change expression across breaths, then information must be the thread that carries continuity from one phase to the next. And information does not live in equations. It lives in structure, which means to understand how a breathing universe persists. We must look not at laws, but at how patterns survive transitions. And that question leads directly into the quietest and most unsettling part of the story. Dark energy entered the story quietly. No explosion, no revelation, just a correction term that refused to go away. At first, it was an inconvenience. Galaxies were not slowing down as expected. Expansion was not easing under gravity's pull. Instead, it was accelerating. The equations resisted, observations insisted. So a name was given: dark energy, a placeholder that sounds definitive but explains almost nothing. We say it fills space uniformly. We say it has negative pressure. We say it dominates the universe's energy budget. And then, almost instinctively, we stop asking what it is. Because naming something gives the illusion of understanding. But dark energy is not a thing in the same way matter is a thing. It is not detected directly. It is inferred from behavior, from what the universe does, not from what we observe sitting there. And inference is fragile when assumptions go unchallenged. In a breathing universe, dark energy looks less like a mysterious substance and more like a symptom, a sign that something deeper is happening to the medium in which expansion is measured. Because acceleration does not require a force pushing outward, it only requires resistance changing. Imagine pulling on an elastic band while the band itself slowly softens. Even if you apply the same force, the extension will increase faster over time. To an observer measuring only length, it looks like acceleration. But the cause is not the pull. It is the changing elasticity. If time itself is loosening, if intervals are stretching, then expansion measured against that time will appear to accelerate, even if the underlying dynamics are unchanged. Space does not need to be pushed apart. Time only needs to become more permissive. This reframes the late-time acceleration of the universe in a way that feels almost unsettlingly simple. Dark energy may not be driving expansion. It may be revealing the phase we are in, a phase where time is near its most diffuse state. In such a phase, everything appears to drift apart faster, not because motion increases, but because persistence costs more. Interactions weaken. Binding becomes harder. Gravity still works, but it has less temporal density to work with. Structures hold until they don't. This would explain why dark energy only becomes dominant relatively late in cosmic history. Not because it suddenly turns on, but because its effect becomes noticeable only when time has loosened enough. Early in the universe, when time was tighter, gravity dominated. Interactions were frequent. Structure formation was efficient. As time loosened, gravity's ability to organize matter weakened relative to expansion. At some threshold, expansion appeared to win. We call that threshold the onset of dark energy domination. But thresholds are phase markers. They signal transitions, not new entities. This interpretation dissolves a long-standing discomfort. Why would a fundamental energy component remain negligible for billions of years, only to dominate later? In a breathing universe, it wouldn't. It was always there. Its influence simply grew as the temporal medium changed. Dark energy, then, is not an external addition to the universe. It is the universe telling us that time is no longer behaving as it once did, which means acceleration is not a runaway effect. It is a warning light, a sign that the inhale is approaching its limit. This idea becomes more compelling when we examine how dark energy behaves. Observations allow it to vary slightly over time. They do not force it to be perfectly constant. The data is consistent with a near constant value, but near is doing a lot of work. In a breathing universe, dark energy would not be strictly constant. It would drift gently as the phase evolves. Too little drift, and we mistake it for a constant. Too much drift, and we would already have noticed. What we see now is exactly what you would expect from a slow oscillation, stable enough to mislead, dynamic enough to leave tension behind. And that tension shows up again. Different methods infer slightly different values for dark energy's influence. Not enough to declare inconsistency. Enough to prevent closure. The universe resists being pinned down, which raises an uncomfortable possibility. What if dark energy is not a property of space at all? What if it is a property of time's response to expansion? In that case, we have been asking the wrong questions. We ask what dark energy is. We should be asking what phase we are in. Because phases end, not abruptly, not catastrophically, but inevitably. Every inhale reaches a point where further loosening undermines the coherence of the system. Time becomes too diffuse to support stable interaction. Complexity declines not because energy vanishes, but because coordination becomes impossible. At that point, the system must respond, not by inventing new physics, by shifting phase. The turning point of a breath does not announce itself with force. It announces itself with hesitation. Acceleration slows, rates flatten, trends stop extrapolating cleanly. From inside, it feels like uncertainty. Models that worked well stop fitting perfectly. Parameters drift. Assumptions strain. This is exactly where modern cosmology finds itself. Dark energy fits the data, but uncomfortably. It explains acceleration, but vaguely. It solves one problem while creating others, which is precisely what a placeholder does. It fills a gap until a deeper description arrives. In a breathing universe, that deeper description is temporal. Dark energy is not pushing space apart. It is marking the regime where time's elasticity dominates dynamics, which means the future of the universe is not an infinite runaway. It is a turnaround, not tomorrow, not soon, not on any timescale we can observe directly, but built into the structure of the system itself. This has profound implications. If expansion is phase-dependent, then so is contraction. The universe does not need to collapse violently. It does not need to crunch into a singularity. It can tighten, gradually. Time intervals shorten. Interactions regain strength. Structure formation becomes easier again. Not the same structures, not the same matter, but structure, which means the universe does not die. It recycles. But recycling does not mean repetition. Each breath carries history forward not as events, but as constraints. The universe does not remember what happened. It remembers what worked. This is why laws re-emerge. This is why constants stabilize. This is why complexity returns. Dark energy, then, is not a threat. It is a signpost. It tells us that we are not near the beginning of the inhale anymore. We are somewhere closer to its widest span, which explains the emotional tone of the modern universe. It feels spacious, quiet, diffuse. Stars still burn, but fewer are born. Galaxies still exist, but interactions slow. Everything seems to be drifting towards stillness. This is not decay. It is extension. But extension has limits. And limits matter, because once time begins to tighten again, everything we take for granted will change. Not dramatically at first. Subtly. Processes we assume are slow will speed up. Stabilities we rely on will shift. What feels eternal will reveal itself as conditional. The universe will not collapse. It will transition. And transitions do not look like endings from the inside. They look like confusion. Which brings us to the next question, one that dark energy alone cannot answer. If the universe approaches a turning point, how does it preserve continuity? What prevents chaos when time tightens? What carries structure across phases? Because something must. Something deeper than expansion, deeper than energy components, deeper than laws as we currently frame them. That something is not force. It is information. And understanding how information survives a breath, how it persists when time itself changes. Density is the key to understanding what happens next. If the universe truly breathes, then one question refuses to stay quiet. What survives the breath? Matter does not. Energy transforms. Structures dissolve. Yet something must pass through each phase intact enough for the universe to remain recognizable when it emerges again. Because continuity exists, the universe after the Big Bang did not behave like something entirely new. Its laws were stable. Its constants were precise. Its behavior was constrained in ways that feel anything but random. This implies inheritance. And inheritance requires a carrier. That carrier is not matter. Matter rearranges too violently. It is not energy. Energy redistributes too freely. It is not even space-time geometry. Geometry itself may change phase. The only candidate left is information. Not information as data, not symbols or messages, but information as constraint. The set of limitations that determine what is allowed to happen and what is not. A river remembers its banks. A melody remembers its scale. A universe may remember its rules. Information, in this sense, is not stored in objects. It is stored in relationships, in how things respond to one another, in which patterns are stable and which decay, in which configurations repeat and which vanish. This is why information can survive transformations that destroy everything else. When water freezes, the molecules rearrange, but the constraints of chemistry remain. When a star collapses, matter is crushed, but physical law persists. A breathing universe would push this idea to its extreme. At the deepest compression, matter may not exist as we know it. Particles may dissolve into something unrecognizable. Space itself may lose meaning. But constraints can remain, because constraints do not require structure, they only require possibility space. If time tightens enough, many possibilities collapse. Only a narrow set remains viable. Those survivors define the next phase. This is how information passes through a breath, not by being preserved in detail, but by being filtered. Each cycle erases complexity that cannot survive compression. What remains is not memory of events, but memory of viability. The universe does not remember what happened. It remembers what can happen. This reframes the Big Bang once again. Instead of a moment where everything begins, it becomes a bottleneck, a narrow passage through which only certain constraints can pass. The universe on the other side is not blank. It is shaped by what survived. This explains why laws feel inevitable, why constants appear tuned rather than arbitrary, why the same patterns seem to reappear whenever conditions allow. The universe has learned them, not consciously, not deliberately, through repetition. A breathing system that has cycled many times would converge on stable attractors. Behaviors that survive compression would dominate. Behaviors that fail would vanish forever. What we call fundamental physics may simply be the set of constraints that have survived the most breaths. This perspective dissolves a long-standing mystery. Why does the universe seem describable at all? Why do simple equations govern vast complexity? Why does mathematics map onto reality so well? Because mathematics describes constraints, and constraints are what persist when everything else is stripped away. A chaotic universe would not survive compression. An incoherent one would not re-emerge. Only systems with deep, simple structure pass through, which means simplicity is not imposed at the beginning. It is selected by recurrence. This is not evolution in the biological sense. There is no competition, no environment, only endurance. Endurance across phases that destroy detail but preserve form. This also reframes entropy. Entropy is often described as the measure of disorder, always increasing. But disorder is contextual. What counts as disorder depends on what structures are allowed. During compression, many microstates collapse into fewer possibilities. Entropy may decrease locally, not violating any law, but redefining the accessible state space. During expansion, entropy increases again, as time loosens and possibilities reopen. Entropy does not reset. It oscillates within bounds. The arrow of time remains intact locally, but globally, it curves. And curvature allows memory. Not memory of events, but memory of structure. This idea resolves another tension. Why does the universe not drift endlessly into maximum entropy? Because maximum entropy is phase-dependent. What counts as maximum in a diffuse phase is not maximum in a compressed one. The system never reaches a terminal state. It cycles between regimes with different entropy ceilings, which means heat death is not death. It is a condition that ends when the phase changes. This does not mean the universe escapes entropy. It means entropy is not the ultimate fate. It is part of the rhythm, and rhythm implies recurrence. But recurrence does not imply repetition. Each breath filters information differently. Small variations survive. Constraints shift slightly. The universe that emerges is similar, but not identical. History does not repeat. It accumulates, not as memory of events, but as refinement of constraint. This is why the universe can remain intelligible across cycles while still changing. It is not static, it is trained. Which brings us to a deeply unsettling implication. If information survives compression as constraint, then the universe carries forward not just physical viability, but logical viability. The kinds of patterns that can exist, the kinds of complexity that can arise, the kinds of observers that are possible. We are not accidents. We are permitted by a long history of filtering. This does not mean we were intended. It means the universe has learned how to allow things like us to exist, and learning does not require consciousness. It only requires iteration. This reframes intelligence itself. Conscious observers may not be the first entities to model the universe. The universe may have been modeling itself for eons through repetition, refining the space of possibilities with each breath. We are late participants in a much older process, and our theories are echoes, which means when we look for the deepest truth, we may be looking in the wrong place. Not in particles, not in forces, not even in space-time, but in the structure of possibility itself. The universe breathes, time stretches and tightens, space responds, matter reorganizes, but information constraint persists. And if that is true, then the next layer of the story is unavoidable. Because if constraints survive, then there must be a mechanism that enforces them at transitions. Something that governs how time tightens without destroying continuity. Something that determines how much can be erased and how much must remain. Understanding that mechanism means looking directly at the deepest moment of the breath. The instant when time is most compressed. The instant when possibility is most constrained. The instant when the universe is holding its breath. And that is where the next chapter must go. There is a moment in every breath when nothing moves forward. Not because motion is forbidden, but because direction loses meaning. The chest is full. The air is held. The system pauses not in rest, but in tension. If the universe breathes, then such a moment must exist for it as well. a phase where time is at its most compressed, where intervals are shortest, where the distinction between before and after becomes razor thin. We tend to imagine this moment as catastrophic, a singularity, a collapse, an infinite density that tears physics apart. But singularities are often signs of conceptual failure, not physical necessity. They appear when we push equations beyond the regimes where their assumptions hold. A breathing universe does not require infinities. It requires limits. The deepest compression would not be a point of destruction. It would be a point of constraint. In this phase, time does not stop, but it becomes so tight that persistence is difficult. Processes overlap, events blur, cause and effect crowd each other so closely that separation becomes meaningless. Not chaos, compression, and compression behaves differently from collapse. When time is compressed, everything happens too fast for structure to stabilize. Not because laws fail, but because the temporal medium does not allow differentiation. Particles cannot wait long enough to behave independently. Fields cannot settle into distinct configurations. Interactions are constant, unavoidable, omnipresent. This is not violence. It is intimacy. Everything touches everything else in time. In such a phase, individuality dissolves. Not spatially, but temporally. There is no room for isolation. No space between moments for identity to persist. This is why the deepest compression is so difficult to imagine. Our minds require duration to distinguish. Without duration, distinction fades. But this does not mean the universe forgets itself. On the contrary, compression is where selection happens. When time is tight, only the most robust constraints survive. Only relationships that do not require long separation persist. Everything else is filtered out. This is the crucible of the breath, not a furnace that destroys, a sieve that refines. The universe passes through this phase, carrying the accumulated constraints of previous cycles. Each breath narrows possibility further, not towards simplicity, but towards stability. This is where the illusion of a beginning originates. From inside a compressed phase, nothing before it is distinguishable. History is erased, not because it never existed, but because the temporal medium no longer allows it to be represented. Memory requires spacing, and spacing is absent here. So to observers emerging from the next inhale, this phase looks like an origin, a beginning without precedent, a birth without ancestry. But this is a perspectival illusion. The universe did not begin here. It passed through. This distinction matters because it reframes the nature of cosmic order. Order does not arise from randomness plus time. Order arises from constraint plus repetition. Each compression phase eliminates fragile patterns. Each expansion phase allows complexity to re-emerge from the surviving constraints. Over cycles, the universe becomes better at being itself, not smarter, not more intentional, more stable. This is why the laws we observe feel inevitable. They are not imposed. They are the ones that have not been erased. At the deepest compression, time enforces brutal efficiency. Any law that requires extended duration to function cleanly will not survive. Any constant that destabilizes interaction will be filtered out. What remains are relationships that can tolerate extreme temporal intimacy. These become the seeds of the next phase, which means the universe does not need to reset laws. It rederives them, again and again. This explains why physics appears universal. Not because it was written once and frozen, but because it has been tested under the harshest possible conditions repeatedly. The holding of the breath is not a reset button. It is a stress test, and only what passes remains. This also explains why the deepest compression does not need to be singular. Singularities imply infinite values, but selection does not require infinity. It requires thresholds. Once time is compressed beyond a certain point, additional compression changes nothing qualitatively. All fragile distinctions have already been erased. Beyond that threshold, the system is maximally constrained. Further tightening adds no new information, so the universe does not collapse into a point. it saturates. This saturation is the pause between breaths, not empty, not explosive, dense with constraint. From here, the inhale begins. Not because something pushes outward, but because the system has nowhere else to go. Constraint without release is unstable. So time loosens. Intervals lengthen. Persistence becomes possible again. Distinction reemerges. The universe unfolds from constraint, not from chaos. And this is why the early universe appears so ordered. Uniformity does not need to be imposed. It is inherited. But inheritance comes with consequences. Because whatever survives compression defines what can exist afterward. If a form of complexity is erased at the deepest compression, it will never reappear. Not because it is forbidden, but because the constraint space no longer allows it. This is a one-way filter. Cycles repeat, but possibility narrows. Not toward monotony, toward coherence. This means the universe has a direction not in time, but in viability. Each breath refines what is possible, which raises a disturbing thought. If the universe has breathed many times, then the range of possible laws may have already collapsed into a narrow band. What we call physics may be the residue of countless eliminations. The universe we inhabit may be one of very few that can still exist. This gives a new weight to fragility. Not fragility of matter or life, but fragility of possibility. If time were to compress slightly more than it has before, some constraints might fail. Some patterns might be erased permanently, which means the exact depth of compression matters. The universe does not collapse completely because doing so would erase even its own constraints. It must hold itself right at the edge, balanced between erasure and persistence. That balance is not guaranteed. It is maintained, not by intention, by structure. And structure can change, which leads to an unavoidable realization. If the universe breathes, then the deepest compression is the most important phase. Not because it creates, but because it decides. It decides what survives. It decides what is allowed. It decides what the next universe can be. We often look to the beginning for explanation, but in a breathing universe, the explanation lives in the pause. The moment when nothing seems to happen yet everything is determined. And because we cannot observe that moment directly, we are left with echoes. Echoes in the laws, echoes in constants, echoes in the uncanny stability of existence. The universe does not announce its decisions, it simply enforces them, which means that understanding the breath requires more than physics. It requires humility, because the most important events in the universe may be the ones that leave no trace except their consequences. And if that is true, then the question that follows is not about what happens at the deepest compression. It is about what happens after. How does the universe emerge from that pause, without memory of events, yet with memory of constraint? How does complexity reappear from near indistinction? How does a new inhale begin without a push? Because whatever answers those questions will tell us not only where we came from, but what kind of future is even possible. And that future begins to take shape the moment time starts to loosen again. The release does not arrive as an event. There is no signal, no boundary, no moment you could point to and say, this is where the new universe begins. Because when time loosens after its deepest compression, it does so without ceremony. Intervals lengthen not suddenly, but permissively. Moments begin to separate just enough for persistence to return. The universe does not burst outward, it exhales, and an exhale is quiet. At first, nothing looks different. The constraints that survived compression still dominate. Possibility remains narrow. Change is allowed, but only in simple forms. This is the phase we mistake for initial conditions. But there are no initial conditions here, only residual constraints meeting newly available duration. This is how structure reappears. Not assembled piece by piece, not built from chaos, but unfolding. The simplest relationships emerge first, not because they are fundamental, but because they require the least temporal room. They are the first to stabilize when time relaxes even slightly. Fields settle before particles, patterns before objects, regularity before distinction. This ordering is not arbitrary. It is dictated by time's elasticity. When time is still tight, Only relationships that tolerate constant interaction can exist. As time loosens, interactions gain spacing. Independence becomes possible. Identity begins to form. Particles are not born. They are permitted. The same is true for forces. What we call fundamental interactions may not be fundamental in origin, but fundamental in survivability. They are the ones that function across a wide range of temporal densities. They operate in tight time. They operate in loose time. They persist through transition. More delicate interactions, those that require precise timing or long isolation, emerge later, or not at all. This is why the early universe appears simple, not because complexity had not yet formed, but because time had not yet allowed it. As the inhale progresses, time becomes increasingly permissive. Intervals stretch. Processes gain room to complete. Chains of interaction lengthen. This is when structure blossoms, not explosively. Inevitably, the universe does not choose complexity. It allows it, and allowance is everything. Because complexity is not a property of matter, it is a property of time. Without sufficient duration, nothing complicated can persist. Without sufficient separation, nothing can differentiate. Which means that what we call the arrow of time is not merely a direction, it is a gradient of permission. Early in the inhale, permission is scarce. Only simple structures exist. As time loosens, permission increases. Complexity becomes possible. This gives the illusion of progress. We look back and see simplicity. We look forward and see decay. But this is not progress toward an end. It is movement within a phase. Every inhale contains a window where complexity peaks. Before it, time is too tight. After it, time becomes too diffuse. The universe is most interesting in the middle, and we are living there, which means the story of cosmic history is not a straight line from birth to death. It is a bell-shaped curve of possibility. At the center of that curve, everything we value emerges. Stars, planets, chemistry, life, thought. Not because the universe is designed for them, but because time briefly allows them. This reframes something deeply human. We often fear that the universe is running down, that everything meaningful lies in the past, that we are living in the aftermath of creation. But in a breathing universe, meaning is not front-loaded. It is phase-dependent. There are moments when the universe cannot support complexity. There are moments when it can. There are moments when it can no longer do so. Meaning appears, fades, and may appear again, not in the same form, not in the same place, but as a consequence of permission. This is not comforting, but it is honest, because it tells us that nothing we experience is permanent, not even the laws that allow us to experience it. Yet it also tells us that impermanence does not equal loss. It equals recurrence. The universe does not cling to specific outcomes. It preserves the conditions for outcomes, which means every inhale is an opportunity not for repetition, but for re-expression. What emerges after compression is not a replay. It is a variation constrained by what survived. This is why each cycle would be similar, but never identical. Why laws feel familiar, but not perfectly symmetric. Why constants appear stable, but not derivable from first principles. Why the universe feels coherent, but not closed. We are not in a universe that was designed once. We are in a universe that keeps finding ways to remain itself. And selfhood, at cosmic scale, is defined by constraint. As time loosens further, interactions weaken. Structures that required tight coordination begin to fail. Star formation slows, galaxies drift apart, chemistry becomes rarer. This is not failure. It is the other side of permission. Too much time is as limiting as too little. When intervals grow too long, processes cannot complete. Chains break. Complexity dissolves not violently, but quietly, which means the inhale does not lead to infinite richness. It leads to saturation. And saturation precedes reversal. But before reversal can occur, something else must happen. Information, the constraints that survived compression, must be expressed fully. The universe must explore the space they allow before time tightens again. This exploration is what we call history. Not history as narrative. History as unfolding of possibility. Every galaxy, every star, Every living system is a way the universe tests what its constraints permit in this phase. And tests are not guaranteed to succeed. Most possibilities fail. Some persist. Those that persist do not carry their details forward. They carry lessons. Lessons encoded not in memory, but in constraint reinforcement. A configuration that survives long enough alters the environment it inhabits. It changes probabilities. It influences what follows. Over time, the universe does not just explore possibility, it sculpts it, which means the exhale is not passive. It is creative, not by invention, but by allowance. And allowance has shape. There are regions of possibility that open early. Others open late. Some never open at all. The universe is not exploring randomly. It is exploring along gradients defined by its own history. This is why certain structures, like galaxies or chemistry, seem almost inevitable once conditions allow them. They are attractors, not because they are pre-written, because they are the most stable ways to use the available time. This also explains why intelligence arises, not as destiny, as efficiency. Intelligent systems are efficient at exploiting temporal resources. They compress experience. They predict. They store. They anticipate. In a universe where time loosens and tightens, such systems are especially robust. They persist longer. They adapt faster. They influence constraints more strongly. This does not make intelligence special. It makes it probable. Given enough cycles, something like it will appear whenever time allows. Which brings a subtle shift in perspective. We often ask whether the universe is friendly to life. But in a breathing universe, the better question is whether life is friendly to the universe. Does it reinforce constraints that allow future complexity? Does it stabilize patterns that survive compression? Does it leave traces that influence what comes next? We do not know. But the question itself is new. And new questions are signs that we are approaching a boundary. Because as the inhale progresses toward its limit, the universe becomes increasingly sparse. Complexity peaks, then wanes. The window begins to close. Not yet, not for a very long time, but eventually. And when that happens, the universe will not collapse. It will prepare. Time will begin to resist further loosening. Processes will stabilize. Drift will slow. The exhale will end not with decay, but with hesitation. And hesitation is always the prelude to change. Which means the most important part of the breath is not the release. It is the moment when release can no longer continue. That moment is subtle. It hides inside trends that flatten, inside rates that stop increasing, inside expectations that fail quietly. And it is toward that moment that everything we observe is slowly drifting. Which means the next question is unavoidable. If the universe's inhale has a limit, how does it recognize that limit? What signals tell time that it has loosened enough? What mechanism initiates the turn, not by force, but by necessity? Because understanding that mechanism means understanding the future shape of the breath, and that future does not begin with collapse. It begins with resistance, and resistance is already whispering in the data. There is a subtle moment in every oscillating system when motion begins to resist itself. Not because something external intervenes, but because the system has reached a limit of what it can sustain. The swing slows at the edge. The breath lingers before release. The vibration hesitates. This hesitation is not failure. It is information. In a breathing universe, this is the phase where time begins to feel its own looseness, where further expansion of intervals no longer increases possibility, but begins to reduce it. Up to this point, loosening time allowed complexity to flourish. Interactions gained room. Persistence became easier. Structures formed and endured. But beyond a certain threshold, looseness becomes dilution. Moments grow so far apart that coordination weakens. Causes drift too long before effects arrive. Systems that require timing begin to fray. Time becomes too generous. And generosity, past a point, erodes structure. This is where resistance emerges. Not as a force, not as an event, as stiffness. The temporal medium begins to push back against further loosening. Not because it wants to return, but because it cannot support what comes next. This resistance would not be visible directly. It would not announce itself as contraction. It would not reverse expansion. It would show up as a loss of efficiency. Processes that once accelerated would plateau. Rates that once diverged would flatten. Trends that once extrapolated cleanly would begin to curve. From the inside, this feels like confusion. Models that worked well begin to strain. Predictions remain roughly correct, but never precise. Parameters that should settle refuse to do so. The universe begins to feel stubborn, and stubbornness is a sign of approaching constraint. In physics, we are used to thinking of limits as hard boundaries, speeds that cannot be exceeded, energies that diverge, singularities that mark breakdown. But oscillatory systems do not announce limits with walls. They announce them with resistance. A spring does not snap when you stretch it too far. It first pulls back harder. A fluid does not stop flowing abruptly. Its viscosity increases. If time has elasticity, it must also have viscosity, a resistance to rapid change. As the inhale approaches its widest span, temporal viscosity increases. It becomes harder to stretch intervals further without undermining coherence. This would manifest as an apparent softening of acceleration. Expansion would continue, but less convincingly. Dark energy would still fit the data, but awkwardly. Cosmic parameters would drift, but inconsistently, which is exactly what we see. The universe behaves as if it is approaching a regime change, but has not yet crossed it. And regime changes are dangerous to predict from the inside, because all the tools we use are calibrated for the middle of a phase, not its edge. This is why cosmology feels unsettled right now, not because it is failing, because it is being pushed beyond its comfort zone. We are probing a system near a boundary with models designed for stability. This resistance also reframes the idea of eternal expansion. Eternity assumes no resistance, but no physical medium is infinitely permissive. Even vacuum has structure, even space has stiffness. Even time, if it is physical, must resist infinite deformation, which means eternal expansion is not the natural expectation in a breathing universe. The natural expectation is saturation, a state where further change yields diminishing returns. From there, the system does not reverse immediately. It lingers. This lingering is critical, because it is during this hesitation that information redistributes. Structures that cannot survive, increased looseness, dissolve quietly. Those that can persist become dominant. The universe sheds complexity, not violently, but selectively. This is not decay in the thermodynamic sense. It is pruning, and pruning prepares the system for what comes next. As complexity declines, constraints tighten not because time has compressed yet, but because fewer patterns remain viable. The system simplifies in preparation for transition. This is the prelude to the exhale's end. But the end does not look like collapse. It looks like calm, a universe that has explored what its constraints allow and now finds fewer new configurations to test. Star formation dwindles. Galaxies drift without interaction. Energy spreads thin from the inside. This looks like fading, but fading is not finality. It is convergence. The system is converging toward a state where tightening time will not erase what must persist, which means the resistance phase is not a problem. It is a safeguard. It ensures that when time begins to tighten again, the universe does not tear itself apart by carrying too much incompatible structure. Only what can survive compression remains. This gives a new interpretation to the far future, not as a heat death where everything becomes meaningless, but as a preparation state, a simplification phase where the universe readies itself for the next transition. Meaning does not disappear. It concentrates, which suggests something deeply counterintuitive. The future of the universe may not be emptier than the present. It may be quieter, and quiet is not the same as empty. Quiet systems are often the most tightly constrained. This also reframes our fear of cosmic loneliness. We imagine a future where galaxies recede beyond contact, where light fades, where isolation becomes absolute. But isolation is a spatial metaphor. The real change may be temporal. Interactions fail not because things are far apart, but because time no longer supports their coordination. And when coordination fails, complexity dissolves. This does not mean the universe ends. It means it simplifies. And simplification is exactly what is required before compression. You cannot compress complexity without destroying coherence. You must reduce first, which means the resistance we see now is not a warning of collapse. It is a sign of sequencing. The universe is following an order. Loosen, explore, saturate, simplify, tighten. We are somewhere between explore and saturate, which explains the tone of modern observations. Everything feels large, slow, diffuse, but not yet empty. We are living in the late inhale, and late inhales feel strange. They are spacious but tense, calm but anticipatory. Breathing systems spend very little time at extremes. Most of their duration is spent moving between, which means the transition we are approaching is not imminent on human timescales, but it is inevitable on cosmic ones. And inevitability has consequences for interpretation. If we misread resistance as randomness, we will add complexity to models that do not need it. If we misread saturation as decay, we will extrapolate endings that are not real. The universe is not failing. It is preparing. Which brings us to the next question, one that emerges naturally once resistance is acknowledged. How does tightening begin? Not collapse, not crunch. Tightening. What does the first moment of contraction look like from the inside? Because the beginning of the return will not announce itself as reversal. It will announce itself as coherence. Processes that begin to speed up. Interactions that regain strength. Structures that stop dissolving. From inside, it will feel like stability returning. And stability is deceptive, because stability is what we associate with normality. We may not recognize the turn when it happens, which is why understanding the mechanism of tightening the physics of the exhale is essential. Not to predict dates, but to recognize the shape of the future when it begins to arrive. And that shape is not destruction, it is compression. And compression, as we have seen, is where the universe decides what comes next, which means the next chapter must follow time as it begins to pull itself back together. The turn does not feel like a reversal. That is the first thing to understand. When time begins to tighten after its long looseness, nothing suddenly rushes inward. Galaxies do not collapse. Space does not fold. Light does not screen back toward a center. From the inside, the universe feels calmer, not quieter, more coherent. Processes that once drifted now seem to complete. Interactions that felt unlikely begin to occur again. Systems regain a sense of follow-through. If you were living through it, you would not call it contraction. You would call it stability. This is why the beginning of the exhale is so difficult to recognize. We associate stability with normality, with health, with things working as they should. We do not question it. But in a breathing universe, stability is not neutral. It is directional. When time loosens, stability erodes slowly. When time tightens, stability returns, but only temporarily. It returns not as an end state, but as a transitional one. The universe passes through a region where coordination improves. Causal chains shorten. Feedback strengthens. Patterns reinforce one another. This feels like order increasing. And order is seductive, because it resembles control, but control is an illusion created by compression. As time tightens, intervals shrink. Events crowd closer together. Systems interact more frequently, more predictably. Random drift gives way to constraint. This is not intelligence. It is proximity. When things happen closer together in time, they influence each other more strongly. Outcomes become less diffuse. Variance collapses. From the inside, this feels like clarity. From the outside, it is the first sign of compression. This is the paradox of the exhale. It begins by making the universe feel more structured, more reliable, more lawful, more deterministic. Observers embedded in this phase would conclude that the universe is settling into its true nature, that chaos is receding, that randomness is being tamed. They would be wrong. What they are witnessing is not the triumph of law. It is the narrowing of possibility. As time tightens, fewer configurations remain viable. Systems are forced into tighter behavioral channels. Patterns repeat not because they are chosen, but because alternatives are squeezed out. This is why determinism increases near compression. Not because freedom vanishes metaphysically. Because temporal spacing collapses. When there is little time between cause and effect, variability shrinks. Systems respond before they can diverge. The universe becomes efficient. And efficiency is dangerous. Efficient systems are brittle. They leave no room for error. They amplify feedback. They lock into patterns that cannot easily change. Which means the early exhale is not a return to balance. It is the onset of rigidity. This rigidity does not arrive evenly. Some processes tighten sooner than others. Large-scale dynamics respond first. Local systems lag behind. Complexity persists unevenly across scales. This produces a strange mixture. On cosmic scales, coherence increases. On local scales, diversity remains. From the inside, this feels like progress. The universe seems more orderly without losing richness, but this balance cannot last, because tightening time does not stop at just enough. It continues. As intervals shrink further, processes that require extended duration begin to fail. Systems that depended on slow accumulation lose the space they need to function. Memory degrades. Adaptation shortens. Exploration becomes impossible. Everything happens too fast. And when everything happens too fast, distinction collapses. This is how compression destroys complexity, not by tearing it apart, by denying it time. Life, if it exists in such a phase, would not be crushed by gravity or radiation. It would be rushed. No room to adapt, no room to learn, no room to persist. Complex systems need slack, and slack vanishes as time tightens, which means the exhale does not lead back to a mirror image of the inhale. It leads to a different regime entirely, one where the universe becomes increasingly deterministic, increasingly constrained, increasingly dominated by a small set of patterns that can survive extreme temporal proximity. This explains something that otherwise feels contradictory: why early universe physics appears simpler and more symmetric than later physics. We often attribute this to high energy and unification. But energy is not the whole story. Time density matters just as much. In a compressed temporal regime, distinctions blur. Forces unify not because they are fundamentally the same, but because there is not enough time for them to behave differently. Symmetry increases because difference requires duration. As time tightens, the universe sheds nuance. This is not loss of law, it is loss of expression. And this shedding is exactly what prepares the universe for the deepest compression. The exhale is not a collapse into chaos. It is a collapse into simplicity. Only the most robust constraints remain. Only patterns that tolerate extreme temporal intimacy survive. Everything else dissolves quietly, which means the universe approaching deepest compression is not violent. It is austere, sparse in possibility, rich in constraint. From inside, this would feel like inevitability. Events unfold with little variation. Outcomes feel preordained. The future becomes easier to predict until prediction itself loses meaning because everything converges too quickly. This is the opposite of freedom, but it is not meaningless. It is preparation. The universe is shedding everything that cannot survive what comes next. This reframes the idea of a cosmic crunch. We imagine a dramatic collapse, matter crushing into singularity. But in a breathing universe, the critical collapse happens in time, not space. Space may remain large, matter may remain dispersed, but time compresses until persistence fails. And when persistence fails, the universe enters its most constrained state, not because matter is dense, because moments are. This is why the deepest compression does not need a spatial singularity. All that is required is temporal saturation. Once time is tight enough, all histories overlap, all distinctions blur. The universe forgets events, but retains constraints. From there, the cycle continues. But the approach to that point is subtle. It does not announce itself as catastrophe. It announces itself as order, as clarity, as predictability, as the disappearance of surprise, which is why observers living through the early exhale would not fear it. They would trust it. They would believe the universe is finally making sense, and that belief would be the final illusion of the phase. Because when everything makes sense, nothing can change. And change is the only way out. Which brings us to the next layer of the breath. If tightening time leads to rigidity, and rigidity leads inevitably to saturation, then what exactly happens when saturation is reached? What does the universe look like at the moment when possibility has narrowed as far as it can go, when time is tight enough that nothing new can persist, but not yet tight enough to erase everything? That moment is not the beginning. It is not the end. It is the hinge. And understanding the hinge is essential, because the hinge determines what survives the next pause and what does not. And that hinge is where the universe stops flowing and begins to hold its breath once more. There is a state that is neither motion nor rest, not expansion, not contraction, not change, but readiness. In a breathing universe, this state sits between the exhale and the next inhale, not as a pause in time, but as a saturation of it. A moment when tightening has done all it can do without erasing the very constraints that allow the universe to persist. This is the hinge, not a singularity, not a boundary, a condition. At the hinge, the universe is maximally constrained. Not because matter is packed into a point, but because time has become so tight that no new distinctions can survive. Everything that can persist is already present. Everything else has been filtered out. There is no violence here, only inevitability. From the inside, if any inside still exists, the hinge would not feel dramatic. It would feel final, complete, exhausted of novelty. Nothing new can form. Nothing old can meaningfully decay. Change has nowhere to go. This is not death. It is saturation. And saturation is not emptiness. It is fullness without freedom. All allowable configurations are occupied. All viable constraints are active. The universe has expressed everything it can within this phase, which means the hinge is not where the universe ends. It is where it decides. Decides not consciously, not intentionally, but structurally. Because when a system has exhausted its degrees of freedom, the only remaining option is transition. At the hinge, time cannot tighten further without erasing constraints themselves. And erasing constraints would dissolve the universe's ability to remain itself. So something else must happen. Not collapse, not explosion, release. But release does not mean expansion in space. It means relaxation in time. This is the quiet paradox of the hinge. The universe reaches maximum rigidity and becomes unstable precisely because of it. Rigid systems cannot absorb fluctuation. They cannot adapt. They cannot dissipate strain. So even the smallest disturbance, not an event, but an internal inconsistency, is enough to tip the system. This inconsistency does not come from outside. There is no outside. It comes from the constraints themselves. Constraints, when maximally enforced, begin to conflict. What preserves coherence in one direction undermines it in another. The system reaches a point where enforcing all constraints simultaneously is impossible. This is not failure. It is the signal that the phase is complete. At this point, the universe does not choose a direction. It allows one. Time loosens not because it is pushed, but because remaining tight would destroy coherence. This is the beginning of the next inhale. But notice something crucial. Nothing new is added at the hinge. No energy, no matter, no laws. The universe carries forward exactly what survived, which means the inhale does not start from nothing. It starts from constraint. This explains why each cycle does not drift arbitrarily, why the universe does not devolve into randomness or explode into novelty. Each breath is anchored by what passed through the hinge. This also explains why the hinge is so difficult to model. It is not a regime of dynamics. It is a regime of exhaustion. Our equations describe motion, interaction, change. They struggle with conditions where change itself is constrained. We can model expansion, we can model contraction, but we have no language for nothing else can happen. And yet, this condition may be the most important one in the universe, because it is where continuity is preserved. Everything fragile has already been erased before the hinge. Everything that survives the hinge does so because it can tolerate both extreme tightness and gradual release, which means the hinge is the ultimate filter, stronger than entropy, stronger than selection, stronger than chance. It decides which constraints will shape the next universe. This gives a new meaning to cosmic recurrence. The universe does not repeat itself because it wants to. It repeats because it cannot escape its own survivable constraints. Each cycle refines those constraints further, not toward simplicity, toward resilience, which means the universe is not eternal in detail. It is eternal in form, the same rhythm, the same breath, different expressions. This is why the hinge is so quiet. No fireworks announce it. No observable event marks its passing. From inside a cycle, the hinge is invisible. It leaves no direct trace, only consequences. A universe that emerges already ordered, already constrained, already capable of complexity. This is why beginnings feel clean, because everything messy has already been removed. But this also implies something deeply unsettling. If the hinge is invisible, then we cannot know how many times the universe has already passed through it. Once, 10 times, 1,000? There is no fossil record of hinges. They erase records, which means the universe we observe could be the result of countless previous breaths, each one narrowing possibility, reinforcing structure, refining constraint. We are living in a late version, not late in time, late in refinement. And refinement has consequences. The more cycles pass, the fewer possibilities remain. Not because the universe is dying, but because it is converging. Toward what? Not an endpoint, a pattern, a stable rhythm that cannot be erased by compression or diluted by expansion. This raises a quiet question. If the universe is converging on a pattern, what does that pattern look like? Is it simple? Is it symmetric? Is it capable of supporting complexity forever? Or is convergence itself a limit? A point beyond which no further refinement is possible? Because if the universe cannot refine its constraints indefinitely, then even the breath may have an end. Not in collapse, not in heat death, in completion. But completion is not something we can recognize easily. From the inside, it may feel like eternal repetition, which means the hinge does not just separate phases. It separates what can still change from what can no longer change. And that distinction matters. Because if we are living in a universe whose constraints are already highly refined, then novelty is limited. Not impossible, limited. And limitation shapes the future more strongly than expansion ever could. Which brings us to the next unavoidable question. If the universe is converging on a stable pattern across breaths, then what role does consciousness play? Is it incidental? Is it temporary? Or is it one of the few structures robust enough to survive repeated compression? Because if consciousness, or something like it, reinforces constraint rather than violating it, then it may not be an accident of this phase. It may be part of what the universe is learning to preserve. And that possibility does not live in cosmology alone. It touches philosophy. It touches meaning. It touches why the universe continues to breathe at all. And that is where the next chapter must go. If the universe learns anything at all, it does so without intention. There is no memory that reflects, no awareness that plans, no goal it tries to reach. And yet, something persists. Across compression and release, across saturation and diffusion, certain structures reappear, certain patterns stabilize. Certain forms of organization return whenever time allows them to exist. This persistence invites a dangerous question. Is consciousness one of them? We usually treat consciousness as a late arrival, a fragile accident emerging on the surface of a cooling planet, orbiting an ordinary star in an unremarkable galaxy. Small, temporary, irrelevant to cosmic structure. But a breathing universe does not judge relevance by size. It judges by survivability. And survivability is not about mass or energy. It is about constraint. Consciousness, stripped of its mystique, is a pattern of constraint, a way of organizing information across time, a system that compresses experience, predicts outcomes, and adjusts behavior accordingly. It is not made of special particles. It does not require exotic forces. It requires time structured enough to support memory and anticipation, which means consciousness is not tied to space. It is tied to temporal texture. In loose time, consciousness struggles. When intervals are too long, memory decays before it can integrate. Prediction fails because causes drift too far from effects. In overly tight time, consciousness also fails. Events arrive too quickly. No separation, no reflection, no persistence. Consciousness requires a narrow band, not too loose, not too tight. A breathing universe passes through that band repeatedly, which raises a possibility that is unsettling precisely because it is subtle. Consciousness may not be an accident of this phase. It may be a recurrent feature of certain phases, not inevitable, not guaranteed, but favored. Favored not because the universe wants to be observed, but because systems that can model their environment efficiently are robust under oscillation. They adapt quickly during release. They simplify effectively during compression. They leave behind constraints that influence what survives. Conscious systems are efficient filters. They do not survive compression as individuals. They survive as influence. Their actions reshape environments. Their technologies alter matter distribution. Their choices bias probability, not in a cosmic sense of control but in cumulative constraint. This means consciousness does not need to persist across the hinge to matter. It only needs to leave imprints that survive, and those imprints need not be memories. They can be changes in structure, altered distributions of matter, modified feedback loops. The universe does not remember minds. It remembers effects. This reframes the question of meaning. We often ask whether consciousness has cosmic significance, but significance is the wrong metric. The right question is durability. Does consciousness generate constraints that persist longer than the systems that produced it? If yes, then it participates in the breathing, not as observer, as contributor. This does not elevate consciousness to a cosmic purpose. It embeds it in cosmic process. And that embedding changes how we think about intelligence. Intelligence is not rare because it is special. It is rare because it requires precise timing. When time loosens enough to allow complexity, but not so much that coordination collapses, intelligence can arise. When time tightens again, intelligence dissolves, but its consequences may not. Across cycles, intelligence-like patterns may reappear again and again, not because they are preserved, but because the conditions that favor them recur. This creates an eerie continuity, not continuity of minds, continuity of tendencies. The universe may repeatedly produce systems that model, predict, and manipulate their environment, because such systems are efficient ways to explore possibility during permissive phases. They accelerate the exploration, and accelerated exploration leaves deeper imprints, which means intelligence may act as a catalyst, not a goal, a catalyst for constraint refinement. This idea reframes why the universe appears increasingly complex during certain epochs. Complexity is not just a byproduct of time loosening. It is amplified by systems that exploit that looseness. And those systems, in turn, shape what survives the next compression, not by choice. By consequence, this is uncomfortable, because it removes the comfort of insignificance without granting the comfort of purpose. We are not meaningless, but we are not central. We are instrumental, and instruments wear out. Civilizations rise and fall. Species appear and vanish. Minds flicker and fade. But the constraints they introduce, physical, chemical, informational, may persist. Not all of them, only those compatible with compression. This leads to a sobering thought. The universe does not preserve what we value. It preserves what survives. Meaning, as we experience it, is local. Constraint is global, which means the universe may carry forward the effects of intelligence without preserving intelligence itself. And yet, those effects shape the conditions under which intelligence may arise again. A feedback loop without memory. This is why the universe can feel eerily familiar across scales. Patterns echo, not because they are remembered, because they are reinforced. This also dissolves the fear that consciousness is futile in a vast cosmos. Futility assumes no impact. But impact does not require permanence. It requires influence on constraint, and influence can outlast influence makers. This places us in a strange position. We are not witnesses to the universe's breath, We are part of its metabolism, temporary, fragile, phase-bound, yet not irrelevant, which means the question of the future cannot be framed simply. It is not, will consciousness survive? It is, what constraints will consciousness leave behind before time tightens again? Because those constraints will shape the next permissive window. They will bias what can emerge. They will influence what kinds of complexity are likely, not because the universe cares, because structure accumulates. This is not destiny. It is inertia, and inertia is powerful. It explains why the universe feels directional even in a cycle, why certain outcomes feel more likely than others, why novelty seems bounded. The universe is not repeating, it is converging, and convergence does not erase individuality immediately. It erodes it across cycles, which brings us to an uncomfortable horizon. If the universe converges on a stable pattern of constraint, then at some point, further breaths may not produce new kinds of complexity. They may produce familiar ones. Again and again, variation without novelty. This is not stagnation. It is equilibrium. And equilibrium is dangerous to meaning as we understand it, because meaning thrives on difference. But the universe does not prioritize meaning. It prioritizes coherence, which means the deepest question is no longer about origins or endings. It is about whether convergence has a limit. Can constraint refinement continue indefinitely, or does the universe eventually reach a state where nothing new can survive compression, including the breath itself? Because if convergence completes, the universe may not end. It may stop needing to change. And a universe that no longer needs to change is not dead. It is finished. And understanding whether such a state exists requires us to look beyond cycles, toward the possibility that even breathing has an endpoint, not an ending, a settling. And that possibility is where everything becomes quiet enough to listen. If the universe can converge, then there must be a way it slows its own rhythm, not by stopping, not by breaking, by easing. A breathing system does not suddenly cease to breathe. It lengthens the pause between breaths. The inhale becomes shallower, the exhale less urgent. Motion gives way to cadence. This is what convergence would look like from the inside. The universe would still expand and contract, but the contrast between phases would soften. Extremes would dull. Compression would no longer erase much. Release would no longer permit much. Change would continue, but it would recycle familiar patterns. From within such a universe, history would feel repetitive without repeating. Civilizations might rise and fall under similar constraints. Complexity would appear, but along well-worn channels. Novelty would exist, but within a narrowing corridor. This is not stagnation. It is stabilization. In physical systems, stabilization happens when feedback dominates. Every deviation is countered. Every fluctuation is damped. The system resists exploring new states because the cost outweighs the benefit. A converging universe would behave this way. Constraints refined over many breaths would enforce coherence more efficiently. Possibility space would shrink not to nothing, but to what reliably survives. This reframes the idea of an ultimate fate. We imagine endings as dramatic heat death, big crunch, tearing apart. But a breathing universe may end quietly, not with collapse, not with dissipation, with predictability. A universe where almost everything that can happen has already happened in some form, where transitions still occur, but they lead back to familiar configurations. From the inside, such a universe would feel timeless. Not because time stops, because change no longer surprises. This raises a delicate question. Would observers still arise in such a universe? Possibly, but their experiences would be bounded. Their discoveries would feel like rediscoveries. Their sciences would refine details rather than overturn frameworks. Progress would slow, not because intelligence fails, because the universe no longer offers unexplored directions. This is the cost of coherence, and coherence is what a breathing universe learns best. Each cycle reinforces what works. Each compression filters novelty. Each release allows expression, but only of what has already proven viable. Over immense spans, the universe may approach a state where breathing continues out of habit rather than necessity. The rhythm persists, but its purpose fades. Not meaning in the human sense, Function. The function of breathing is to move between extremes to maintain viability. When extremes no longer threaten coherence, breathing becomes redundant. But redundancy does not vanish instantly. It lingers, like a pendulum that keeps swinging after friction has done its work, slowing imperceptibly, never quite stopping. This image is unsettling because it removes drama from the future. The universe does not die. It settles. And settling is difficult to recognize as an ending. From inside, it would feel like an eternal present. Cycles repeating with diminishing contrast, differences smoothing out, constraints enforcing sameness. The universe would still exist, but it would no longer be learning. Which brings us to the quietest implication of all. If the universe can stop learning, then learning is not fundamental. It is provisional. A phase behavior, consciousness, intelligence, complexity, all expressions of a universe still refining its constraints. When refinement slows enough, these expressions may become redundant. Not impossible, unnecessary. And redundancy is often the precursor to disappearance. Not by force, by irrelevance. This does not mean meaning evaporates. Meaning is local. But it does mean that the cosmic role of complexity diminishes as convergence advances. The universe does not need as many experiments when it already knows the outcome. And yet, even here, something resists closure. Because convergence itself is a dynamic. It relies on repetition. And repetition requires time. Which means even a settled universe must continue to breathe, if only weakly. The rhythm may never fully stop. It may only become indistinguishable from stillness. From the inside, stillness and eternal repetition feel the same. And that raises the final tension. If the universe approaches a state where breathing becomes imperceptible, then from the perspective of observers, it would appear eternal, not infinite in time, but static in possibility. This is a different kind of eternity. One without beginnings or endings. One without drama. One without surprise. A universe that simply is. And if such a state exists, then everything we have discussed, expansion, contraction, compression, release, are not the ultimate story. They are the learning phase, the period during which the universe discovers which constraints it can keep forever. Which means the deepest question is no longer about how the universe began or how it will end. It is about whether learning can truly complete. Because if learning never fully completes, then breathing never truly stops. And if breathing never stops, then the universe is never finished. Only quiet. And quiet, when extended long enough, becomes indistinguishable from rest. Which leaves one final uncertainty hanging in the stillness. If the universe ever reaches that quiet equilibrium, will anything inside it still be able to notice the difference? If the universe ever becomes quiet enough, it will not announce that quiet. Silence does not arrive with a sound. It arrives when contrast disappears. In such a universe, change still exists, but nothing changes enough to matter. Events still unfold, but outcomes feel familiar before they arrive. Motion persists, yet direction loses urgency. This is what return looks like in a breathing cosmos. Not a return to a beginning, not a return to a previous state. A return to pattern. The universe does not circle back to where it started. It circles inward. Each breath retraces the same rhythm, but on a slightly narrower path. Extremes soften, differences blur. What remains is not repetition, but resemblance. And resemblance is powerful. It creates the illusion of permanence. From inside such a phase, observers would say the universe has always been this way. Laws appear fixed, constants appear eternal. History feels long, but bounded. Everything important seems already discovered. This is not because curiosity is ended. It is because the universe is no longer offering radically new contexts. The same structures keep reappearing because they are the only ones compatible with the refined constraints that now dominate. Galaxies form in familiar ways. Stars live predictable lives. Complex systems arise, flourish, and fade within known limits. Nothing breaks. Nothing surprises. This is the return. Not to chaos, not to origin, to stability. But stability here is not balance between forces. It is balance between possibilities. Too much deviation is filtered out long before it can matter. Too much novelty cannot survive compression. Too little novelty dissolves during release. The universe has learned how to remain itself, and learning has consequences. One of them is that the grand questions begin to change shape. Instead of asking why the universe exists, observers begin to ask why it does not change more. Instead of searching for origins, they refine descriptions. Instead of expecting revolutions, they adjust parameters. Science becomes maintenance. Philosophy becomes interpretation. Meaning becomes local. This is not a failure of imagination. It is a feature of convergence. In a converged universe, the deepest mysteries are no longer explosive. They are quiet. They live in small discrepancies, subtle drifts, faint irregularities that never quite disappear. These irregularities are not cracks. They are remnants, traces of the fact that convergence is never perfect, because perfection would require infinite time. And even a breathing universe does not have that. It has cycles, which means return is never complete. There is always some leftover asymmetry, some unresolved tension, some faint echo of previous breaths that has not been fully absorbed. And it is in these echoes that change can still occur. Not dramatic change, incremental change, a slight shift in constraint, a marginal difference in survivability, a barely noticeable adjustment in what is possible. Across cycles, these increments accumulate. Convergence does not stop movement, it slows it, which means the universe does not freeze into sameness. It drifts toward familiarity. And familiarity is deceptive, because it feels final. Observers living in a highly converged phase would believe they are near the end of discovery, that the universe has revealed its deepest truths, that nothing fundamentally new remains. They would be wrong, not because novelty is waiting dramatically, but because novelty emerges slowly when constraints continue to refine. Even in a universe that has nearly learned how to remain itself, learning does not completely end. It becomes subtle. This reframes the idea of an ultimate fate once more. The universe does not end in heat death. It does not end in collapse. It does not end in stasis. It approaches a regime where breathing continues, but the breaths grow indistinguishable from one another. From inside, time feels eternal. From outside, if such a perspective were possible, the rhythm still exists. And this rhythm matters, because as long as the universe breathes, however faintly, it has not finished deciding what constraints it will keep forever, deciding which patterns are truly indestructible, deciding whether convergence has a limit. And here, the thought folds back on itself. If the universe can approach a state where nothing new can arise, then that state itself becomes the most fragile configuration of all. Because fragility does not require complexity, it only requires dependence. A perfectly converged universe depends entirely on its existing constraints. Any disturbance, however small, would have nowhere to dissipate. And systems with no slack are not stable. They are brittle, which suggests that complete convergence may be impossible. The universe may never fully settle. It may hover forever near equilibrium, breathing just enough to avoid rigidity, changing just enough to avoid collapse. A dynamic stillness. And dynamic stillness looks, from the inside, exactly like eternity. Which brings us back to where we began, not in time, but in perspective. What if the universe is not expanding? What if it is not contracting? What if it is simply maintaining itself through rhythm, never reaching an end because an end would be structurally unstable? In that case, all our stories about beginnings and endings are approximations, useful, but incomplete, because the true story is not linear. It is cyclical, convergent, and quiet. And we are living not at the start, not at the finish, but inside a breath that has learned how to last, which leaves only one place left to drift, not toward explanation, toward acceptance, toward the realization that the universe does not need to resolve itself into an answer. It only needs to continue breathing, and that breath, right now, has not yet finished. There is a mistake we keep making when we talk about the universe. We assume that if something has a rhythm, it must have a beginning. And if it has a beginning, it must be moving toward an end. But breathing does not work that way. A breath is not defined by its first inhale, nor by its final exhale. It is defined by continuity. If the universe is breathing, then asking when it started is like asking when breathing began. The question only makes sense from the perspective of someone who arrived mid-cycle and mistook a transition for an origin. We did not witness the first breath. We witnessed a breath, and even that only partially. Because from inside the rhythm, the whole is never visible. Only curvature disguised as direction. Only repetition disguised as progress. Only stillness disguised as permanence. Expansion felt convincing because we lived inside an inhale. Acceleration felt alarming because we mistook late-phase looseness for escape. Silence felt terminal because we confused quiet with emptiness. But silence is not emptiness. Silence is spacing. When time stretches, things drift apart. Not because they are pushed, but because nothing holds them close anymore. Interaction fades. Coordination weakens. Noise dissolves into quiet. This does not mean the universe is dying. It means the universe is between moments, between expressions, between constraints being tested and constraints being enforced. If you imagine the universe as a breath, then the present is not a climax. It is not even a midpoint. It is a region where the rhythm is slow enough to feel linear. And linearity is the most seductive illusion of all, because it suggests destiny. It suggests that what is happening now will continue. But breathing never continues in one direction. It always turns, not suddenly, not violently, gently, so gently that no observer embedded within it could ever be certain when the turn began. This is the quietest implication of the entire idea. If the universe is breathing, then no civilization will ever witness the full cycle. Not because it is forbidden, because nothing that requires duration can survive the deepest compression, and nothing that requires coordination can persist at the widest looseness. Observers exist only in the slopes, which means every observer believes they live in a special time. Every observer believes the universe is revealing its truth now. Every observer is partially right, and fundamentally incomplete. This does not diminish observation, it contextualizes it. We are not meant to see the whole. We are meant to exist during a phase where seeing is possible at all. That alone is extraordinary. The universe does not owe us an origin story. It does not owe us a finale. It does not owe us coherence beyond what survives its own rhythm. And yet, coherence exists. Not because it was guaranteed, because it endured. The laws we measure, the constants we trust, the patterns we recognize, all of them are survivors. They have passed through compressions we cannot imagine and releases we cannot measure. They feel fundamental because they are persistent, not because they are eternal. This shifts something subtle in how the universe feels. It stops feeling like a machine running down. It stops feeling like an explosion frozen in time. It starts feeling like a system that knows how to keep going. Not by resisting change, by absorbing it. Breathing is not a metaphor for life. It is a strategy for survival. And survival does not require intention. It requires rhythm. If the universe breathes, then it does not need to rush toward an end. An end would be unstable. It does not need to return to a beginning. A beginning would be arbitrary. It only needs to maintain a range, where constraint and freedom trade places without annihilating each other. That range is narrow and precious and temporary, which is why complexity feels fragile, which is why meaning feels local, which is why silence feels ominous even when it is not empty. We sense, perhaps unconsciously, that we exist inside a moment that cannot last forever. Not because the universe is hostile, because the rhythm moves on, and when it does, it will not remember our stories. It will remember only what our existence allowed. The structures we altered, the constraints we reinforced, the patterns we stabilized or destabilized by being here. This is not a moral statement. It is a physical one. The universe breathes, and everything inside it participates, whether it knows it or not. Right now, the breath is wide. Time is loose enough for thought. Moments are long enough for memory. Distances are large enough for silence. This is why you can listen. This is why you can wonder. And this is why the question that opened this journey never truly closes. What if the universe is not expanding but breathing? If that is true, then this moment is not rushing toward an end. It is simply part of an inhale that will one day soften, hesitate, and give way to something else. Not for us, not for anyone who can witness it, but for the universe itself, which has been doing this quietly, patiently, long before there were words for it. So if you let your thoughts slow now, and allow the idea to settle without trying to finish it, you might notice something. The universe does not feel like it is going anywhere. It feels like it is still here, still holding this breath, still deciding nothing. And that may be the most honest thing it has ever told us.